Check, check. All right. Huh. Not a lot of people around today. Tuesday, I guess. Tuesdays are odd days to stream. Hey! God damn it. Tuesdays are an odd day to stream. Monday is the one where nobody's around. I think everybody just hates Mondays. All right, let's get this stuff cleared off here. Clear off all the surfaces that I need in order to operate. I think that's okay. Let's see here. You. I like just wolfed down a hoagie, so I'm a little burpy. fucking around trying to get VR working yesterday, and the whole block of time that I had to play a VR game, I ended up troubleshooting the headset. And it turns out it was either one or a combination of a bunch of plugs that were not quite seated properly. It's not that they weren't seated properly, it's more that, like, they just needed to be unplugged and plugged back in. For mine, at least, the order of operations is to get all of the plugs plugged and then unplug USB and plug it back in. And somehow that suddenly got it to work again. I was like unplugging the lighthouses and all the, you know, trying to get all the stuff to show up. Like, if you don't get the headset recognized, that's it. You can't get into any of the other settings. You can't verify anything else is working unless you do that. It's a nightmare, man. It took me a long time to get that running. And then it finally, right when I was gonna give up, and today's stream would have been putting the new motherboard into the computer case, because I was about to give up on all of it. And then right when I was making that decision, it decided to start working again. Ridiculous. Are you hyped about the Diablo 2 remake? I was never really a big Diablo player, to be honest. I was never a big Diablo player. I liked it, I played it a little bit, but I don't know, ADHD clicking game. Nope, copyrighted song. Copyrighted song. Yeah, I liked it. I liked Diablo, but I never really played it a lot. I don't know, I play kind of weird games. Where are we going? We're going to Metronomic Live. Where's that browser window? Here it is. Boop, boop, boop. We got a copyrighted song. Don't send the police. What is my favorite game? Oh man, that's tough for me to say. I'm gonna rank Kerbal up there. What do I have the most hours in? That's a good question. Maybe Fallout? New Vegas? I have a lot of hours in. A lot of Xbox hours. They're not on my Steam account. Obviously, Skyrim has the most number of hours, I think, on my Steam account. I don't know, there are a lot of good games. There are a lot of good games. It's easy to name good games. Games that I really love. I would love to do a stream of Kerbal. What's up, engineer? Yeah, Skyrim VR was something that I would love to check out, but my VR headset's been a dick. So, it's been an absolute nightmare. You do strike me as a Kerbal guy. Give me a good sandbox any day of the week, man. I don't know if all my Kerbal hours are on Steam. I don't know if those are logged. I think it's one of my top games. Right up there with Skyrim. But the problem is like a lot of the hours that I did in New Vegas and Skyrim, a lot of those hours are me asleep with a controller in my hand. Because that Bethesda world music that you get when you run out into the open wilderness and it's like 2 in the morning and you're trying to play this game and you're just like, I gotta walk over to this thing. Man, this is so atmospheric and calming. Asleep. It's terrible. Look at this shit. Look at this shit. Spent a lot of work on this. Spent a lot of work on this 3D model here. I put in the connectors. None of them really fit because I didn't change the camber or caster or whatever. So I'm not really trying to exactly fit it. I'm just trying to kind of put stuff in a place so I know what's where. It'll help me, maybe. Yeah, I got everything modeled in this. It's kind of awesome. It's kind of awesome. This has been, I don't know, it'd be nice if they gave you a log of how much time you've spent working on a particular drawing, because I'd love to know what the breakdown of hours is on this one. How many hours does it take to get something like this? It took me a shit ton of hours to get all the holes right, so yeah, maybe I don't want to know the hours. There's one more part. Meh. There we go. So I'm debating on whether or not I do 1 screw or 2 screws to hold down the ECU. Because I will do a pin here. That'll just be a post that comes up and has a pin. Because you can't get to the other side, right? There'd be VHB tape or whatever on that. So you won't be able to get to the other side of that. But those two are right up top dead center, so you will be able to get to them. So it's appropriate to put screws there. It may or may not. I may do 1 screw and 2 pegs. Probably 2 screws. 2 screws will hold it on there pretty robustly. My concern is when this thing goes into a death roll after I perform a turn a little too fast. Carpet fibers will probably catch these corners right here. I just moved that. No, Control Z. Carpet fibers will probably catch these little corners right here and try to rip the modules away, which is why I'm like, maybe I want something 3D printed to kind of like be a little interface between the circuit board and the platen there. But before I go ahead with this design, by the way, we need to do today's work of trying to filter out that motor noise. I've been meaning to get back to this for quite some time. I've got the diodes in the design, the 1N4148s, and the auto package generator was supposed to make that a white bar. It didn't. It's like, all right, whatever. As long as it's the right size. How thick is your carpet? It's a pretty dense carpet, but I mean, these things rolling up against it at like 900 miles an hour, it happens. Stuff happens. When did we get Dervinter on the board? 4 days ago, 4 days ago, 4 days ago. Yeah, I guess we did. Oh, wait. There we go. Bit Looney followed an hour ago. Hey, thanks. That's quite a question to ask someone publicly. How do I ban a mod? I want to click off of this select here, but I can't because there's stuff everywhere. There. So that's the 0.1 F cap that's going to filter the motor. I've got pads, which all the markings on the board aren't done yet, but must be so satisfying to make something engineered as efficiently as possible. It's fiddly. It's a lot of fiddly work, a lot of details, and details will kill you. Details will fucking shiv you out back. Why is there like is that the copper layer? Must be no. What is that little extra layer on there? 2 pads on the bottom for power input, 2 pads on the top for motor. Okay, come on. 2 pads on the top for motor. What is happening here? Why is this moving at a glacial speed? Because we're inside of the battery? Yeah, it is. So yeah, 2 pads on the top for the motor, 2 pads on the bottom for power, and then the motor wires are going to come out and around to the terminals so that they can also hold up the power wires that are going to go to the switch and then the battery. I'm debating whether or not I want to put another circuit board just to hold a battery connector in here, or if I want to flip the battery in the other direction so it plugs in over here. Took me a little bit on GrabCAD to find a model for a switch. I found this switch, and then the switch, like the slider thing, was too long. And so I took that file and I did a press pull, and I did a press pull on all of these pieces, and it actually moved it down properly. I didn't expect that to work. Didn't expect that to work, but it worked. So yeah, I've got a model of the exact micro switch that I'm putting into the thing. That's kind of cool. I appreciate that. Kind of helps me round out the rest of the model, you know? I mean, I'm missing screws in a lot of the different places here, but that's fine. The whole point of this is it's like a size model. But yeah, I made the shocks, and the shocks even had the right color anodized red, which is a little bit deeper than the typical anodization of the other parts that I bought. These parts have a different anodized color than this. In real life, that's actually what the real thing looks like. I mean, here. Whoop. It's very, very close. Oh wait, we're actually looking at this. I'm feeling a little funky today. We'll see how long I end up streaming. but I definitely need to do the circuit work, because even like if I'm sick, I can work on the circuit still. But streaming is a totally different set of stressors. So have you tried one of those 3D mice before? Yeah, I do actually have one. It's sitting on a shelf right now. I moved it. Yeah, it's been plugged in for months, but I moved it off because I got this area of just like mess behind the keyboard where it used to live. The 3D mice, I mean, the 3D mouse is pretty cool. It's a lot of fun to use in Fusion if you've got like a larger drawing, because you can fly around and like tour stuff. If you're doing like architectural engineering in CAD, it is a wonderful tool because you can take people for walkarounds and stuff. Now I've been trying to figure out, and that's part of why I did VR last night. I was trying to figure out how to do Fusion CAD models and get them into VR. There is a plugin, and I don't know if it's $300 or not. And there's also, it's like not an official plugin. I gotta get a haircut. I'm starting to mullet. I'm starting to get a little bit of a MacGyver going on back there. I don't know whether or not, what am I trying to say? There is a plugin, but I think that was like an old solution. And there's like, some people were saying just treat it like a game and take the 3D model into the game and develop a game for it. I'm like, that's a lot of work. It would be nice if you could fly around your CAD model in VR. I think that would be an awesome feature that Fusion could just build in easily. But yeah.
Oh, Dizzy Maid, welcome back.
Talking.
Good to have you live. And thanks for the 15 months. That's a long time. Thanks for the support.
Yeah, look at that MacGyver going on back there. I gotta get that handled. I gotta get a haircut.
The gift to
it's about time.
Monica 4.
How's everybody doing today? We're gonna be doing circuity stuff for this. I shouldn't talk at the same time as somebody else is talking. Oh my god, I killed him. Metro, no, he's dead. He's dead. Was it worth it? Yeah, pick it up and mangle it. If I did all the motion modeling on this thing, it would be pretty cool. I get shamed by my barber for waiting too long. Hey, it's the best way to look fresh, man. If you're starting to feel kind of dumpy, do a lot of those hygiene things. I gotta be better about brushing my teeth. Well, that's a little bit of a problem. I think I'm gonna start brushing my teeth in the morning. But yeah, I gotta, do all the hygiene stuff, right? Brush your teeth, comb your hair, do all that stuff, get a haircut, trim your beard. Don't look like a scraggly mountain man, Floss. I should floss. I got a Sonicare, right? I got a Sonicare a while back, like a long time ago, and my dentist visits. Okay, he's talking again. He's talking again. Metro. What have I said about talking? He's allowed to talk. It's his stream. Yeah, I hear the water picks are like the fucking nuclear solution in terms of like cleaning between teeth, like instead of flossing. I hate flossing. I really do. I know the use that it has, and I do have like the little single-use things stashed away somewhere. But I got a Sonicare like a long time ago, and my dentist visits went from a horrible bloodbath to, hey, your teeth look pretty good. That was it. Tooth shower. It was insane. Like the first dentist visit after getting the Sonicare, and like I hadn't gone to a dentist in a long time because I moved back to Philadelphia, and the dentist looked at my teeth and she was like, "Yeah, fine." Oh, really? Tooth shower is an actual product? Floss at night, water pick in the morning. Why would you let that stuff sit between your teeth overnight? You just need to engineer a mouth bit that does that all. just like a thing you bite down on. Yeah, I don't even want to know what my dentist is gonna say. I haven't been allowed since COVID. My the dentist place that I used to go to closed down. I went there and it was like a long hallway of stations. There were like something like 30 dentist chairs just all in a line, and they were all empty. When I went there, I'm like, how's this tenable? Like, what is it? There's like nobody here. Nobody's getting dental work done. It was like a UPenn like teaching place, and yeah, it closed down. I wonder what happened to all that. I wonder what happened to all that equipment. What's up, Proteus? I did a lot of modeling for things that I didn't need to model, like ball joints. Mine's an old Victorian mansion. That's you walk into an old Victorian mansion to hear dentist drills and people screaming in like a couple rooms over. It's like it's basically a Resident Evil game.
Someone asked what I'm drinking tonight.
I've always wanted to break into that industry. How'd you become a ball model? It takes a lot of practice. It's a lot of practice.
It's a Modelo. They're making
Takes
this Modelo
cojones.
Chelada now. I don't know
What?
if you've ever had a Chelada, but it's like a Colombian drink. It's just a light beer. And lime in it. Like a lot of lime and a lot of
He's
salt.
talking so much during this set.
But until then, it stays in the bag.
But yeah, notice how even the difference in color of the shocks comes through in the model. All right. There you go. For your comparison, lighting is obviously different. The lighting is different, but I need to get this light over here if we're gonna be doing some breadboarding work. We'll get started in just a second here. I'm a little late. Anyway. I think I did a little bit of toe in on the rear. No, did I? Yeah, a little bit of toe in on the rear and a little bit of camber. So the wheels tilt in a little bit, which is why these parts don't fit. Like I meticulously measured the size of the ball joint and stuff. Same with these, and same with these. Oh wait, no, the rear linkages. The rear linkages, I actually I filed them down a little bit, so they're shorter than the typical one. And they sit at a funky angle. As displayed. All right, so let's get started. I'm not in the business of having hour-long podcasts in front of the stream, but I do like to give everybody a chance to convene. So yeah, the person from the other day got into the Discord. Am I not? Oh, it's control. Why am I dumb? Got into the Discord and you know, gave me a bunch of advice about noise and RC snubber circuits. I don't know if we're gonna go through the trouble. I don't think we are gonna go through the trouble of calculating an entire RC snubber circuit. I think maybe the solution here is what's right in front of our nose. Adding a bunch of diodes to my H-bridge circuit probably will solve the noise issue. So we need to get my motor test setup back on the bench, and we need to test that again. What's been happening with the RC car is I have been in the background designing the circuit board. So I've got the circuit board, and I've got the design, and I've got a bunch of the traces laid out, but not all of them. Dun, dun, dun. Because I don't know how we're going to solve the noise issue. This capacitor right here is just holding, it's just a like a position holder, just in case I need a real, like, I probably do need a big capacitor on this, just to be nice to the rest of the circuit. Big capacitor that sits after the H-bridge, and the H-bridge itself probably needs these diodes in place in order to keep the weird transients that occur when you break contact with the coil and then engage contact again with the coil in a rapid succession. That kind of stuff causes a lot of noise, and there's all kinds of different capacitor circuits that you can do in order to snub the noise, but I don't want to solder a bunch of capacitors to my motor terminals. There is one big unifying capacitor, 1.1 UF, higher vol current, I don't know, whatever. There's one larger 0.1 UF that's going to sit right where the motor connects. What people do with these things is they also add capacitors from the terminal to the body of the motor, and somehow that snubs a lot of the excess weirdness that comes from these things. But I don't want to solder stuff to the cans of my motors. I don't think it's necessary. I want this to be as modular as I can possibly make it. So I got a capacitor over here, and I got diodes over here. What we're going to do is we're going to try to make that circuit and see if it works. See if it snubs the weird transient blip that we are getting from this circuit. I mean, this circuit, there's some blip, and that blip causes the ECU and the radio. It wouldn't be so bad if it didn't take out the radio, but it takes out the radio, which is extremely frustrating because then you got to wait for it to do a little handshake, a little RF handshake with the transmitter. So yeah, that's what I'd like to take a look at today. I'd like to solve that so that I can get back to routing traces on that board, because this board is extremely compact and I'm having a lot of trouble getting stuff from place to place. I need to start working on the large bits of it over here. These guys need big traces in order to carry all that current to the motor, which is right there, from the power, which is coming in, you can't see it, on the opposite side, basically. All right. Oh yeah, there's software that can test circuits, but it's the software that people use to simulate circuits is like a practical joke against electrical engineers. Like, I don't know, it's not easy to use. It's really annoying. And actually, I think Fusion's trying to like wrap something into this where you can test your circuits in the same software suite. There are probably better programs out there now, but what's wrong with Spice? Spice is everything is wrong with Spice. Fucking hate that program. No, I don't like simulating circuits. Simulating circuits they can help sometimes, but I don't see any need to go through that headache. Spice is obnoxious. Spice is one of those programs where it won't simulate until you click 50,000 times and figure. They probably improved it since I used it. I used it back in like the 2005, right? Like so. Yeah, precisely. That's why we use breadboards. Why am I so thirsty? Hold on. Usually that's an indicator. I think I forgot to bolus. Oh no. No, I'm doing good. All right, we'll ride that out for a little bit. I'm just thirsty because my body needs water, I guess. All right. The circuit. I want to drop it, but I also don't want everything to fly all over the place. We'll do that. How's that? That's good enough. All right. So I brought out the big breadboard in order to test this shit. We've got two modules on the breadboard. One of them is the old MOSFETs. These can certainly handle the current. The other one is the new MOSFETs. Look at how much smaller they are. How much smaller they are. The new MOSFETs, we've discovered, can handle the current. They're actually perfectly fine to dissipate all the heat, which is pretty awesome. I'm going to ban Fatanon for too many Spice Girls references in too short of an amount of time. Jesus Christ. I didn't mean to go to this camera, but I'll act mad. I'll act mad because I went to the wrong camera. Damn you, Fatanon. I'm Okay, anyway. Back to the proper cam. Oh my god. Why is there so much light and shakiness? All right, hold on. I gotta do the... I have to calibrate this camera. Configure video. Look at it shaking and it's all bright. I'm sorry, chat. The gain is at 175. Why is it... Why? Why did Logitech was like, this seems good. I'll put the gain all the way up here. All right, FPS 30. Click. Oh, look, see the gain went away as soon as I chose 30. Why does it do this? Configure video. Gain went all the way back up to 171. Just because there's a joke to be made doesn't mean you guys need to make it. You know? I don't know why that's a tough concept for chat to understand. All right, properties again. Go to 60, rather highest. Oh, did you see that little blip? Yeah, Logitech, I'm on to you. Configure video. We can put the gain up a little bit so that we get like a good image, because it's not like, oh, this is particularly dark. This is my problem. This is my problem with dad jokes, is that it's just any joke you can possibly make. Right? It's not a good joke. It's just any joke. Why does this look so close? We're like way too close for this. Okay, that didn't work at all. All right, that's, I guess, far enough away for us to operate. Man, that's really shaky. That's really sensitive to shaking today. I tighten some stuff down. See if that helps at all. No, everything's tight. It's just really, really, really shaky today. No, the actual purpose of dad jokes is that they're safe, right? They're not like edgy at all. They're just safe jokes for dad to be like, I'm a rumble bumble good guy. Hey, everybody's having fun. Like, it's really irritating. Like, they're not, like, you don't have to make any joke. You can make a good joke. You could try that out. Just try it out. All right. Yeah, so we got our H-bridge circuit here. I need 1N4148s to add to this thing. Man, it is really hard to figure out what the fuck is going on this board. This is something that we made, and boy oh boy, is it ever tiny. We can add diodes directly to this. We can just plug it right in. We can just plug it in. Yeah, that you guys earned me ignoring you now because of these dumb jokes. All right. You guys earned that. So where were we with this? Where were we? I need to figure out what was going on here. Now, where we left off, we were having a lot of trouble with getting this thing to run seamlessly, right? I've got the radio all the way over here. That appears to be connected to our motor controller. This is the ATtiny85. We did an extensive amount of programming. I'm gonna get a pointing device because my fingers are kind of dry today. Spent too much time in the shower. So we got our ATtiny85. We've got 2 capacitors on it in order to filter out noise. That's connected to power. It's connected to the H-bridge and the 4 pins that it connects on. Over to here. We have our inverters. These are inverting the signal coming out of there so that we can have status LEDs on the different directions, right? So inverting, going over to the P channels, and then the positive activated going over to the N channels directly. The P channels are pull downs because they're positive channel FETs. So they get an inverter on them, making them positive signal control. That way, when this turns off, these don't activate because that would be bad. Over here, I've got a big capacitor and I have 1 Schottky diode. I'm going to move the Schottky diode off of the circuit for now. We got a Schottky diode over here. So our thought was, I'm gonna cough. Hold on. Man, I'm feeling something in my throat today. I don't know what the fuck it is. Something bad. I think I didn't sleep. I think I didn't sleep like fucking at all well. Maybe I snored big time and like damaged the back of my throat. Anyway, so yeah, Schottky diode. What the Schottky diode was supposed to do, it was supposed to, when the motor did like a big blip, it was supposed to block that blip, and then the rest of the circuit would survive off of the big capacitor for however many nanoseconds. But that appears to just not be working. So our solution is, instead of the big Schottky diode, and I might keep the Schottky diode, I'm not really sure about that yet. Instead of the big Schottky diode, we're going to put 1N4148s in the H bridge so that it can absorb those blips in itself. Right? So the circuit, I guess I can open the design. Here, let me open this. That would be this one. I need to clean up these files, by the way. It's getting a little crazy. Open this up. It's going to open like 16 files, so everything will lag. By 16, I mean 3 files. Look at all this garbage that it puts on the screen. Okay, all right. What are you doing? Here we go. Go away. Go away. There we go. So, boop, 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 boop. I got the diodes in here already because I already put them on the design. We got to put these in here, these 4148s. They will block reverse current, or they'll block forward current, and they will allow reverse current to be filtered out. So if there's a positive here, isn't that going to filter that out? I don't know. Well, apparently that's the scheme. Because, like, if that pin is connected to negative, current, no, that should be blocking. To negative, that should be blocking. But then if there's a positive here, it'll go there first, I guess, instead of through the diode. I don't like this. we got a bi-directional controller here. Oh, what's this doing here? Get out of here. There we go. There's all my workspace. Okay. Yeah, we got all this stuff here. Oh, jeez, this is, you know, like so many windows. Okay, are you done? Jeez. They really need, like, Fusion Eagle really needs to streamline their library management, because there's like 50 different windows. It's like impossible to get to just the one window that you want to get to. The whole process is completely convoluted. It just needs work. It needs work. It needs a top-down redesign. It's a very powerful piece of software. You can do a lot of really cool stuff with it, but getting the workflow to be appropriate. And there's always people defending it too. Like, I just click around randomly and everything worked out just fine. It's like, yeah, but like, have you really used the software? Have you really looked at it recently? All right. So anyway, this is the advice, is putting in diodes like this. I don't know which ones are the P's and which ones are the N's on this thing. First, we got to find 1N4148s. So I guess that's going to take some rooting around. I thought we'd have to reconfigure the breadboard, but it turns out I put it back into the configuration that we want. What we did is we put the original DOS Micro H-bridge motor controller with the big MOSFETs on a really low current motor, and we still got the power down error. So this is like, I was at a loss for what to do at this point. I didn't want to add the 4 diodes. We'll try adding the 4 diodes and we'll see if this thing can run the motor a little bit without having a blip. It could also be that everything is spread out so much. Yeah, the library manager should be independent so you can make proper shared libraries in a Git-like environment, but they want it integrated. It's terrible because of it. There's 2 chip builders. One is the in-program chip builder, and the other one's the one that exists in library.io, which is madness. What I want to be able to do, and I don't think a Git-like environment is necessarily the answer. I think what I'd love to have is something very similar to what already exists, but I need the ability to go through it and pick and place all of my different components into one big list that is my library and have that as like a file or a repository online. Just one thing, and I can pick and choose and drag stuff around. They use library.io, but then they closed it off. So you can't publish parts to like the public, which is madness. It's absolute madness. Software in general, are you saying? Software needs an update intervention? The obsession with updates has taken over your life? Yeah, maybe. Pope Pontus, thank you for the raid, man. What are you guys doing over there at Pope Pontus? What do you guys work on? What's up, Hacker Man? 69420 botter. How you doing? It's the Pope. How you doing, man? All right, so I'm gonna look for my 4N, 1N, 4 whatever. Hell on earth trying to play an audio file through Node. Oh man, we got some people who know Node around here. All right, one of these is gonna be the right thing. Not on this one though. I also have a whole like binder full of diodes. Nearly 1.5 hours and nada. Ah man, everything's in Linux and I'm on Windows. I feel like that sometimes. I feel that. I feel that. I feel ya. Life is pain. Ah, that's rough. That is rough. Rough with a capital F. I have absolutely no idea what's in here. There's some capacitors. I definitely have 120 ohm resistors. Why does that get its own bin? Like off to the side. What is this? Oh, a lot of clocks. Okay, this is where I keep my clocks. Well, you guys have all seen my clocks. You bringing a bot in here? We ban bots. 3904. No. We're looking for 1N4148, and I'm pretty sure I got a bin of them. Oh, it's only on your channel. Okay. No bots. It's a bot-free zone. LEDs, LEDs, LEDs. At Mega AU 1A SO. No, that's a 2N2222222222 equivalent. AT Tinies, coils, 1N914. That might be the ticket. There's none. There's, oh god, oh, they're so small, I can't even see them. They're, look at the size of these fucking things. Well, if we can use the 1N914s, I guess I could probably do that. I should order some of these. Jesus Christ. They don't. They're memory order. I haven't, these are the miscellaneous surface mount parts, and I've just kind of barely labeled them. I need to label the remainders. It's just a lot of work to do the labels. You just kind of got to sit down with a labeler and, you know, cut the edges of them and everything. Here's what my high roses. Okay, so that's the Schottky. Hot damn, I guess I ordered them recently. Got a lot of Schottkys. We're not using Schottkys. I guess we could. Nah, we probably shouldn't. I think that was the diode bin. There's also the book of diodes. The good book of diodes. I don't know where I put it. Where did I put those fucking things? Oh, they're over there. Oh, those are Zener diodes. Never mind. I don't know if I've got a book of generic diodes. Yeah, if you got magnification and steady hands, they're not that hard to work with. You broke my thing. Well, thanks for the follow, Hacker Man. And Bizarre Steph. All right, so if you didn't know, we got a little tiny RC car. That much should be clear. I have this little tiny RC car, and it is full of noise. I'm working on redesigning the motor mount so that it takes a different, this 130 sized motor. Different motor, different battery configuration. Smaller servo, which was a bonus, that's allowed me to potentially design a circuit that's going to fit in this little cubby hole right here above the servo. How am I confident that it will actually work? Well, believe it or not, I've modeled the entire RC car frame. This has been over months, just as like a labor of love. I've had a lot of the parts already in Fusion. What this has taught me is how to organize your Fusion design. If you're putting together something like an RC car, there's a lot of different like sub-assemblies, like a shock is a sub-assembly, or the steering linkage. These linkages are sub-assemblies. In order to put this thing together, what I've done is you design a part, put it in an assembly, and then in your main drawing, hold on. Ugh, I gotta drink fluids because otherwise I'm gonna nuclear burp myself into oblivion. In your main design, what you do is you get all of your parts in there in one giant step. What I've done is I've grouped all of the insertion of part steps, right? So all my files, all of my sub-assemblies and parts are taken in at the same time. And once that's done and they're all put in position, there is one singular parts location freeze. So that step, if I roll back to that step, all of the additional stuff has disappeared, right? And so we've just got parts floating in space. So if I'm gonna add any of the parts that additionally make up this frame, like if I want to, and it may come to that, design that little foam front bumper and put that in, I can do that in a separate file because it's gotta have a couple things like foam and then the bumper piece, right? So make that part in a separate file. Then I would roll the history back to the second to last thing on this group, pull the part into the drawing, and that's gonna make another one of these little gearbox logos, the component being added to the drawing. And that'll be inside the group. I mean, you can ungroup and regroup if you really feel like doing that. I don't. I just insert it. You know, I roll the timeline back to where I'm in that group, and then I put the part in, and it's in that group. It's just easier to do that way. Anyway, and then I double-click the position step, my Omni position step. That brings me into this special step editing kind of reduced functionality menu, where the tools I get are just move, align, and delete. So then I can put the parts into alignment where they belong and then finish that step in the timeline. That way, my timeline isn't completely fucking exploded. If I want to factor in those parts that I've designed into, you know, like, oh, this is in the way, then rolling back to the drawing for that part doesn't obliterate stuff. The timeline gets really weird when you mess with it too much. So yeah, doing an omni group of parts insertion, lock it down, then you start making sketches and stuff in order to create the parts that you're gonna 3D print or whatever. So it's a little convoluted over here with locking down the position because I added screws to the circuit board, and this step right here is adding the circuit board. So once I finalize the circuit board in terms of its shape and size, I'll delete these steps and then put them in where they belong. You can also use the base feature if you wanted to. I'm not sure how to do that. I don't know what that means. This is the way that I learned to do this. So it might be wrong, but it does work for me. I still need to lift this up a little bit. The theoretical size of the AT-Tiny85 is clipping a little bit. But anyway, I'm just showing you guys what the project is. Never wrong if it works the way you want. Yeah, I haven't played with like edit in place or base feature. I haven't messed with those. Stuff like in terms of Fusion, the best thing you can do, everything is on a timeline, right? Everything happens in a sequence of events, and your job is to preserve that sequence of events. You're a time cop, basically. Because when you open up the program, it will reconstruct everything based on that sequence of events. So if you start messing around with, oh, I want to move this chamfer here or this here, you can break stuff down the timeline. The only thing that I want to have to repair on the timeline is the lines for the stuff that I've extruded in terms of these sketches. So if I move a screw hole on the base platen because it's not actually in the right position, this is something that I've had to do quite often, move a hole on the base platen, that's going to move this extrusion possibly because I've projected this hole onto my sketch, And if that extrusion moves in such a way as to create a new area, like a new open area that confuses the software because it hasn't been told to extrude that area, it can break stuff. But if that's the only problem you have, it's easy to go through all the different steps of the timeline and repair the various different extrusions that make up your solids. So that's been the saving grace of this complicated of a project. This is something I didn't know how to do before. And I just basically learned how to handle all this stuff. Oh my God, I'm burping hard today. This is bad. Almost an engineer. Hey, thank you for the sub. That went to Deck of Dragons. Oh my God. He has a Deck of Dragons. All right, let's put him up on the board. I think I activated the board. Pretty sure. This is the other thing this channel has, which is a giant laser etching table on the wall. What allows us to put names of subscribers up onto the board. Oh, there it goes. Oh, it almost took a full second to place that. It's impressive. Yeah, the 3D model is a little bit out of control, if I'm honest. Like, I didn't need an extensive 3D model of the RC car. It's been really fun to do. I kind of wish it was my own RC car design, because, you know, it's not like I can manufacture this thing. This is the wltoys 989 kit. I've just reverse engineered it and put it into CAD. I mean, I guess I could probably, like, say, you know, share it somewhere, but... Animal Groin subbed with Prime. Hell yeah, dude. We'll see if you snipe somebody by going up into the board while this thing is jogging home. Deck of Dragons, welcome to the board. Thanks to Almost an Engineer. I appreciate that gift sub, man. Every little bit helps. Helps me do weird bullshit like I'm doing right now. Oh no, it looks like it went in while it was burning. So you do not get to snipe somebody. Animal Groin. But thank you, Animal Groin, for the 8 months. It's awesome. Hell yeah. Is that a Tesco thing? We don't have Tesco here. I guess I can't say that. There's probably a Tesco in America, right? Is there a US Tesco? I saw a Lidl the other day. Lidl. Aren't they Scandinavian or something? I don't know. Just to hear you say it went in when it was burning. Oh no! Perverts. Can't get anything by you guys. Oh, there we go. I gotta move the camera. Animal Groin, welcome to the board. Cars, haven't you followed before? They're German, okay. China, the Czech Republic, Hungary, Japan, Malaysia, Poland, Republic of Ireland, Slovakia, South Korea, Thailand, and Turkey. Huh. We don't have Tesco's. Animal Groin, welcome to the board. You're by Ding. And the big Rob Oz. Okay. You guys can't tell, I'm not firing on all cylinders today. Yes, this is an old account reused. I feel like, you know, I got a weird memory, you guys. I don't know, I've been credited with having a really good memory, but I don't think that's true. But yeah, I don't know. I like remember stuff weirdly. I feel like I'd seen the name Cars before. Yeah, so this spring right here, by the way, this is from a group of springs that were 3D printable springs. It was off GrabCAD, right? I made the little adapter part, which is literally what's actually there. But this spring was from GrabCAD, and it was closest to the design of the springs that I actually have. It's literally just a placeholder. So I did some press pulls on the outside in order to get it wide enough, and then I rounded out the edges, and then I took the color of the piston and I applied that to the outside, and then I just made the inside parts nickel. And I had to scale the whole thing. I had to scale the whole thing down in order for it to be the right size. So it got me close enough, though. Close enough that it's all right. I mean, I could I could try to model the actual spring, but I don't feel that that's necessary. I just need to know that a spring is there and it's taking up a certain amount of space. So a lot of this stuff is just so that everything looks cool, right? If we're honest. We don't have Walmart anymore? Yeah. It got sold to a petrol station group for $6.8 billion. That's crazy. So yeah, anyway, I've been trying to make this circuit board populate the available space that I have. It looks like it fits perfectly. It is a tight squeeze because I got to go under the whatever this top bar thing is. It's funny. I could actually put like a speed sensor on the axle and put like a component under there, but I don't know. I need big traces in this area, so I'm going to need both sides of the circuit board in order to perform all of the different layout tasks that I have. The speed sensor is not going to do anything for this. I can't, it's not like these do telemetry. I can't like relay information back to the controller. It would be cool, but no. Scope creep. I got to buy, actually no, I already did buy 3-pin connectors for the servo because I got to recrimp that. So I used high rows. That's cutting it a little close, but I think that'll fit. No, I'm not going to do a 4-layer board. That's kind of cheating. Actually, I got most of the traces almost on 1 layer. I almost got all the traces that I need on 1 layer. I've been kind of eyeballing this thing and trying to get it right. Like I've got almost everything wired up except for the transistors to invert the signal and all of this crap up here. So I think I'm in good shape to lay it out. We just need to make sure that the diodes will actually filter the stuff. So the diodes that were called for, I think in the comment, which I mean, honestly, like I should be able to do, I should have known this anyway. VCC. The diodes here are 1N4148s, right? What do we have? 1N914. So 1N4148 versus 1. Look at that! It autofills. This is a common question. Can be used interchangeably. That's all I need to hear. Huh. 4.8 is considered an advanced version. All right. I love that Google just has a thing for that. Ain't the future weird? I'm gonna get more Diet Mountain Dew. I'm gonna over caffeinate because I feel like shit today. I feel like behind my eyes. I don't know if that makes any sense. You might be a little dehydrated, a little underslept. God damn it. I think I was coughing in my sleep because of stomach stuff. This is going to be useful. I never know what to look for with diodes. I know they prevent current flow in one way, but not the other. That's about it. That's all they do. That's all they do. Yeah, that's all they do. A Zener diode is notable because of its ability to have such a sharp increase in current allowed. And what that does is it allows it to regulate the voltage of something. So that reverse drop off of a Zener diode is what allows it to regulate current. There are some other tricksy uses for Zener diodes, but that's sort of the primary use is put them in backwards and they will bleed all of the excess current away in order to maintain a voltage. A Schottky diode is notable because it has a very low drop-off, very, very low drop-off to the point where you can put it in line with a battery, and if stuff is wired up backwards, it'll prevent current flow. Picking a diode. Yeah, I'm not good at that. I'm not good at choosing diodes for stuff. You got to get into the data sheets and look at all the different parameters of your diode and then make sure that there are no curveballs like the reverse breakdown voltage and stuff like that. Boy, oh boy, is it annoying. Capacitors and diodes and RC snubbers, all that stuff, we don't typically include those in the designs here. But they are useful elements. I mean, they would be hard to find on consumer products if they weren't useful. But in my travels, I have not really needed to use them all that much. I don't know. We have two capacitors on our ATtiny 85. One is the typical decoupling 0.1 UF, And then we've got, I believe, a 4.7. We got a larger capacitor on it just to take up any of the additional noise created by our buddy over here. These little motors make a lot of noise. They're not that fancy. They're not that well built, and there are a bunch of coils that are completing and breaking contact constantly. So they're going to filter a lot of noise back into the system. So in the grand scheme of things, these diodes, we'll go to the comment. Hold on, where did I put that window? Oh yeah, it's right here. These diodes' job, ground and power, these diodes' job is to filter out any of those transients. I feel like they would, I don't know. I mean, the MOSFET has like an inherent diode in it, but I don't think it's really doing it much for us here. So, because we tried this circuit with all of the old equipment. We tried it with the old MOSFETs, we tried it with the old motor controller, and it still had weird noise in it that would take out the transmitter, which is just baffling to me because that shouldn't happen. It shouldn't happen. But it might be that these transistors don't have as good of a diode on them. So we'll add an external one. Let's see what it does. So I need to figure out where the hell I'm putting these things. Oh God, this is the part that I'm avoiding. Where am I putting the diodes? Move all this shit out of the way so I can actually work. So what we have here is failure to communicate. I got my 2N2222s. Now let's look at the specific circuit that we have in the actual thing. We've got the lower layer of that circuit board that we could possibly work with. Oh my God, it's a mess. There we go. So, sorry, I said 2N2222s. I meant 2.2K. Pull. What direction are those pulling in? Damn it. Where's my original DOS micro circuit? Stream, projects, DOS, ESC, DOS reverse engineer. There we go. That's what I'm looking for. All right. 2.2Ks are on the P channels. 10Ks are on the N channels. Let's see if that holds water. Yeah. 10K, 10K. Oh God, my finger's disgusting. Hold on, I'll use a pointing device. my finger, it looks like a fucking zombie finger. Jesus Christ. I got just dry skin. I took a long shower. 10K, 10K, 2.2, 2.2, right? So these are the pull-ups, these are the pull-downs. You can see, wired up ground. Okay, so with those there, we basically are putting diodes in parallel to these resistors. Yeah, we are. So I could just pop a diode in next to these guys. All right. This is a lot easier than I thought it would be. I thought I'd have to really figure out where these things are and like, I don't know what I was in for. Okay, so these diodes are the size of a fucking grain of sand. And they are pretty much a grain of sand. That's kind of what they are. A grain of sand with some wires on it and some epoxy around it. So the diodes we're gonna put in go from the motor terminal. That's a fucking homework question. Why are you asking me that? That is a... I'm not here to do your homework. All right, let's see. Quick question, no bother. If a train leaves Chicago going 75 miles an hour... Okay, so we need to go from the motor terminals, the output to the motor. Where the hell's that? It's not as easy as I thought it was. So we need to go to this terminal here. From where? From here. I can go under this and I can install the diode here, maybe. Because that'll go from motor. Yeah, so it'll go here and here. Because it goes from motor terminal to V+. So that's here, here. Because that's V minus, yeah, here. Actually, I could do this on the top. I can fit a diode right there. I can fit a diode right there if I'm clever enough. If I'm tactile enough. All right. let's see what we can do here. So I want the cathode of the diode, the straight block piece, right? The straight line. See, it doesn't even come back with a comment after I call it a homework question. Were you ready for my answer on that one or not? Because I don't fucking know. that sounds like such a homework question. I don't think you're actually curious about that. Yeah, anode and cathode on a diode, right? So the line represents the line. The line represents the line. I can just do the quick Google search for that. SMD diode marking images. Yeah, they're not. I like it when they put the schematic symbol next to it. That's what I'm trying to show. Yeah, this'll do. So yeah, the cathode A minus C plus. No, A plus C minus. For some reason I flipped that in my brain. Old dyslexia. Anyway, A minus, A plus, C minus, A plus C minus, right? Am I right about that? I need to make sure that I'm giving you guys the right information. Yeah, A plus C minus. All right, I was right. I just it's like I'm also Googling this for this visual aid. It's not that I need this necessarily, except that I question myself about it if I recite it too many times. But it's A plus C minus is the mnemonic that I use. Whatever mnemonic you use, the one you choose first is the one that you stick with, right? So A plus C minus. Tights fall up, might scroll down. No, tights fall down, might scroll up. How do I flip shit in my brain? This is what's wrong with my brain. Anyway, anode and cathode. This is how you know which one's which. You can think of it as current going from positive to negative, flows with the arrow, and is stopped until it reaches a certain amount of voltage, until it can push over the little wall. Everybody's trying to sound smart in the comments. I know you guys know this stuff, but for the people that don't, and you guys are also, you're adding information, which is good. But anyway, the simplistic way to think of it is the one that I hate. It's a check valve. It's a check valve. You can think of a little wall as having a little bit of resistance to it. And when you get to the right amount of pressure from the arrow, it'll push it over and the arrow flies through and stabs something. I don't know. But yeah, anyway, that's the way to think about it. I flipped my water meter reading today. Told them I used 187 units, not 178. That could have cost me. Holy shit. Yeah. Yeah, I have a problem with that. That's why I double check everything. Hey, CFG. Hey, Chimera. How you guys doing? So yeah, anyway, that's what we're thinking here, right? So now my task is to put the wall part to the opposite direction, because we want current to flow when stuff is not where it should be. And keep in mind, like when that transistor, or when the transistor is allowing current to flow, it's going to go the path of least resistance and stuff. So yeah, anyway, apparently this is the way to filter it. So whatever. Anyway, little blocky part goes towards positive. Little blocky part goes away from negative. Go to the microscope, because we're going to need it. All right, so I need a soldering iron tip that is not larger than the diode. So let's get out. I think I can do it with this one. I don't think I need the tiny little needle tips. I think that'll do. Who's confirmation biasing? All I'm doing is dyslexically flipping numbers. Don't answer. That's a homework question. They gotta figure it out themselves. All right, so Oh my god, there's two different sizes in here. I don't know which ones are which. I'm gonna choose the larger ones just to be kind to myself. I need 4 of them. Do I have 4 of them? I thought they were all one size. Oh boy. Oh god. Fuck me. They're not the same size. God damn it. That's not always, because mnemonics aren't just one or the other. You know, like, avoiding doing 2 sides mnemonics is a... I don't know, man. I don't know. Okay, all right. We're gonna stick to the tweezers today too. We're gonna do that thing, that old gag, that old bit. Where did that go? Wait a minute. That's under the... Okay. Jesus Christ! It disappeared. It just vanished. It was there one day, gone the next. I kind of wish they were in that larger socket size, huh? Not socket size, the larger surface mount size. I got 3 of 1. Can I use shotkeys? I don't think I can. I need 1 and 4148s or... Oh my god. Why do I have 3 of 1 and 2 of the other? Huh. Okay. Let me see if I've got diodes in another location. I don't think I do, but if one of those books has diodes in it, I would very much like to know. I think one of them is transistors, one of them is Zeners. Maybe the third one is diodes? We can't use a Zener here. That's out of the question. I mean, maybe a certain Zener would have the same properties as a 4148, but with any luck, these are capacitors. God damn it. Fuck. Okay. What do we got? I guess I'm gonna have to order. I'm gonna have to order capacitors because I just don't have them. Or sorry, diodes. I'm gonna have to order diodes. We'll get by with what we got here, but you know, for blah blah blah. I was talking to Julian earlier. These are his old op amps from his Electron. I think he sold that. Desoldered, miscellaneous. No diodes in there. Decovered switch. This one is a MISC. A lot of these are the SparkFun grab bag parts too. Yeah, none of these have diodes in them. There are, however, quite a few. Those are V-Regs. These are big capacitors. Everything is capacitors around here. I don't have diodes. Digipot, Lin receiver. Tiny 87s that I never use. Line receiver, logic and FET layers. Yeah, I don't think I got... No, I don't have Bearer 914s. I don't have that kind of stuff. In the stuff, what about the miscellaneous stuff that chat bought me like 3 years ago? See if I can find that bin. In the bin of bins. All the bins, all the stuff. It's all in one place. At least they'll be able to find it. I just need to find the bin that contains all those parts. I had it right here, I could swear. This isn't that. That's just another one. Yeah, these are a lot of the SparkFun parts that I haven't labeled yet. Buttons. Snakes. Is it always snakes? Yeah, alright. Not seeing them. Looking. What is that? Oh, it's a little computer thing. It's a little computer thing. Tiny fans? Nah, we don't need tiny fans. What are those? Nope. Voltage regulators. Holy shit, I don't even know. I think those are those resonators? What's in here? What are you? Oh, they're little poly fuses. Oh, I didn't even know I had a bin for those. Some resistors. These are, oh boy, these are out of order. Out of order. So what I'm looking for is it's like a little bin, here it is, of parts. The chat, no, they didn't give me any diodes. I got two N3904s, two N2222s, LM324s. These are like basic parts that I didn't have. And they affected a couple projects that we were working on back in the day. And chat was like, for fuck's sake. And so I believe it was Dewey came up with some of the jelly bean parts that I didn't have. So here they are. I've still got them just in case we need them to breadboard, but we don't need transistors. We need diodes, which is a bit of a unicorn around here. I don't have like a misc bin of diodes, so we're gonna have to mix and match, which is gonna be hellacious on this circuit. And if this doesn't work, I mean, I'm gonna have to do it anyway. I'm gonna have to order some, because the 1N914s and the 1N4148s, I should have those, or at least one of those, and a collection of them at that. So now we could look at the forward voltage to try to get a sense of which one's which. The 4148s are the 0603s. I don't know what the other ones are. We're just gonna put them in there, and if they blow up, then whatever. Get out your glass blower and build some diodes. Banned. Yeah, I don't know why I don't have diodes at the ready. You guys, I don't think we're not gonna harvest. We're not gonna harvest parts, are we? Like from the data acquisition card from 1990. I don't think there are diodes on this. There might be. Probably not something we should do. I don't see no diodes. 1997. Nano diodes. See how useless diodes are? This is what you get. This is what you want. This is what you get. Oh no, there's one diode. This is back when they were doing the glass can. The glass barrel diodes, so easy to break. Now we're not gonna harvest it. All right, anyway, back to hell. Back to hell. What's in this bin? Nothing. Oh, yeah. All right, fine. Fine. I'm just gonna say, I gotta order diodes. Stream over. Nope, the show must go on. So we're gonna. Speaking of might scroll up. Tights fall down. That's my mnemonic. For stalactite and stalagmite. You may have this maglite and survive the apocalypse. And for the agile course of a fragile horse, here's a handful of chocolate chips. Sorry, it's from Deltron. All right, so how in the fuck am I supposed to have the type of freaking nuclear powered eyes in order to see where I just flicked that part? No, in order to see the band on this thing. 0603 was a curse. It's a curse. Oh my god. All right, so let's get close. I don't have a zoom lens on this. I can do this. I can move the camera too. That's the alternative. But I think this is close enough that we can see a band. I don't see. Jesus Christ. What are these other parts? Maybe these will be kinder to me. I am gonna probably have to get this size for the end circuit, because yeah, these little guys are tiny. All right, so there's our band. Let's put, I don't know, let's put these on the positive side. So the band is clearly visible. It goes in that direction. Let's move this one up and get it soldered in. So it goes like that. From the motor terminal where the band is facing positive. There's the positive rail. Jesus Christ. This is so small. It's so small. The other ones are going to be even more torture to put in, but we should be able to handle this probably. You get solder over here. Luckily, this thing is all held in place. I don't have to put it on the vise. Although the vise would probably be better because it would actually hold the parts in a good spot. I'm scared. No. I should be able to do this. A hair just like fucking yeeted itself into my mouth. Pah! Let me get a little bit more central. Keep the parts over there. I could turn on thermals, but I don't think I'd... We'll relish the screen space. Relish? I don't know. We'll enjoy the screen space for now. That's too much solder, and it's not going anywhere, so I'm going to scrape it off. That was a failed attempt. Let me do left-hand tweezers. I'll try to work some of the solder that's already there to kind of hold this thing down. Oh, it's held in with flux right now. There we go. Yeah, the flux from that solder held it down, and so the thing that you don't want to do is heat it back up, or the thing that you don't want to do is try to move it and have it break contact, but you're putting too much force into it, and then your part just fucking flies. You just never see it again. I've had that happen. What's going on with the heat from the soldering iron today? Is it really dissipating that well? There it goes. Okay. Oops, that's a little crooked. I'm kind of okay with it being a little crooked. That minor camera shake is really getting to me today. Because it makes stuff look like it's out of focus, but I put a lot of effort into focusing the camera. All right, so that's one. Let's get a little solder on the other side. I can't even confirm the identity of this diode. I don't know what this one is. I don't know if it's a 4148. Let's hope it can survive motor conditions, you know? Why is the solder not cooperating today? There you go. Not with these. These are too small to find later. I don't think these are a find later kind of affair. These are if it's gone, it's gone. Yeah, the iron is not doing as well. I don't know why. Probably just the additional amount of copper that it has to deal with. Okay, I gotta flip that. Oh, I flipped it. Hey, neat. All right, there's the band. It's hardly visible. You guys got to know the insane scale of all of this stuff. I'm working with, you know, some pretty advanced MOSFETs and some miscellaneous stuff that was undersized. And like, here's my finger. That is the size of a human finger. So we're dealing with some small stuff. You can put your finger up against the screen, try to like move it close to your eyes and get a sense for the scale. You can't pull my finger. It's not something we do around here. That was kind of a dad joke. I should practice what I preach, huh? Who pulled my finger? Stop doing that. Yeah, I think there's just like a lot of stuff here. I think that's what's affecting my ability to put heat into this. If I turn on thermals, you can probably see... Oh, wait, it's unplugged. I'm not going to turn them on right now. If I turn on thermals, you can probably see the heat dissipating to the whole thing. Like, the whole board is probably getting hot. I didn't have the diode there for that. Oh, come on. Like, okay. Please find the metal. There we go. That'll do. Man, that's a big blob, huh? That is a big blob. Get over here. What I'm trying, while I'm working, I'm trying to be really careful of these parts right here because they are tiny and I don't want them to go anywhere. You know, like, just please, just, there we go. No, that didn't even, stupid solder. Good enough. All right, so now we have diodes here and here. that are also facing in the same direction as these two. How in the hell am I going to see the band on these things? Tweezers? Tweezers? Hello? Hey there. I can kind of see the band on this side of this one. Is that right? Kind of looks right. If I get this wrong, current will just flow through the diode and possibly blow it up. Good thing I only have so many of them. I guess I can move the camera in further. Yeah, I could use the multimeter to figure it out. But then, in doing so, am I going to send these into orbit? Let's get them up and onto where they go, and I'll get the camera closer in so we can see where they go. I'll put the last one back in the bin. Fuck. Okay, that didn't go far. Please get off of the tweezers. Okay. I hate that. I hate it when stuff sticks to the tweezers. The tweezers are very intentionally not supposed to stick to anything. I guess that's where those ceramic tweezers come in handy, but the ceramic tweezers that I got sent to me have way too much spring tension on them. God, I looked at the screen and read Dewey's message that said tester. And it just came out of my mouth. Focus. Oh, hey, that was the line. Yeah, so if we have extremely enhanced vision, we can see where the line is at least. Look at how sloppy those other ones are soldered in. I guess it doesn't really matter. They don't need to be cleanly soldered in. They just need to make connection. That's what we're dealing with right now. You know, on the circuit board, all this stuff's going to look a lot better. Still a little sloppy, mind you, but better. Dear God, look at the size of the solder. Please, please just get the heat in there. Oh my God, the solder's stuck. Oh, I don't have, my tweezers aren't in reach. Shit. Fuck. Come on, all right. Steady hands, steady hands. Steady. I'm doing this left-handed. I don't trust myself with a 603. Doing this left-handed while talking. You can tell that, like, when I talk, I kind of move the tweezers away a little bit because the movement of my torso is going to disturb the movement of the soldering iron and the tweezers. Soldering iron is at least a little bit more blunt of a tool. I can just kind of park it. Hey, bucko, you wanna? All right, I need to add solder. Let's see if I can do that properly. That little piece of Scotch-Brite pad is annoying. Okay, there we go. It's not Scotch-Brite. What is it called again? Not Brillo. What's that copper pad called? I think I need to get a new one. Damn it. Well, I guess I could do that. I need to get thinner solder. No, it's not copper. It's like brass wool. There's like a product name for it. I don't remember what it is. It is Scotch-Brite? I thought Scotch-Brite pads were the green things. Yeah, Scotch-Brite are the green things. They're really good at cleaning metal. Maybe it's a different Scotch-Brite product or something. That's just Scotch. Oh, Jesus Christ. Oh, come on. All right, we're just going to drown it in solder. Rest in pepperonis. You've been drowned in solder. All right, so we got the tiniest fucking diodes in the world. They're not the tiniest. The smallest diode in the world is probably very small. But yeah, these are annoyingly tiny. What just happened? Are you really not connected at all, or is it just all? Is there that much heat in this area? That's connected, right? I think it just transferred the heat over to the other side. No, it's just not connected. What the fuck? You utter fucking bastard. It looks like it's connected. No, that's just flux shining, yeah. Scotch-Brite copper-coated scubbing coat. It's not copper, though. It's brass. Brass, gas, or sass. Nobody rides for free. I guess that's soldered. Check the other one. That doesn't look... Oh, no, I didn't solder this one yet. I was gonna get belligerent. Come on, buddy. Let's go. Bring the heat. Bring the noise. Bring the something. We're gonna need somethings. I finally sent Octojay's tablets back to him, which looks really bad for me because it took me so long to send. Fuck. It took me so long to send them. Whereas the other Lone Star was just like, "Hey, I got this piece of equipment, and I'm gonna ship it to you eventually," and it came the next day. Like, that really makes me look bad. Fucking Canada tariff and all that stuff. Shipping to Canada, I can ship to California in like an afternoon. As soon as you cross the border to Canada, they just fleece you. And it's like less distance. Just gotta see if I can smooth this up a little bit. It is just a fleecing is what it is. Yeah, welcome to customs indeed. Gotta justify their own existence with a shit ton of fees. Fees. Yeah, shipping to Canada is a beast. All right. That's like some of us have addresses on both sides of the border. I know, like I should have paid a courier to just take shit over. All right, yeah, if you have an address like barely in America, get like an Amazon locker there. Goddamn loonies. All right, talking about their money. I think we're ready to test. This is probably ready to test. Move the camera back up and away. Get the solder out of the way. Presumably, with any luck, I heard a clicking noise and it was just the switch. It was just this thing. With any luck, we chose the right diodes. Cheaper to pay $5 per package to get a store to accept it than it is to send across, huh? That's pretty wild. Okay. What am I forgetting? Got the radio. Got the controller. Got the LEDs. Little capacitors. Inverters. We got the H-bridge that has the pull-ups, the pull-downs. And the motor. Motor has its own capacitor, which is not hooked up. There to there. There to there. 1, 2. It is hooked up. Okay. Yeah, sorry, I made a little breakout board for the motor just to make sure it was mounted properly. And that has its own 0.1 off diode on it. Or sorry, 0.1 off capacitor. It's a little small, but I think it does the job. Or maybe it doesn't. Maybe that's why I'm having troubles with this whole circuit. This has been a major pain in my ass, is getting this circuit up and running. So yeah, power and ground. Where are those coming in? I think we're putting power and ground up on the rail. All the interference is coming from here, although it should be snubbed locally. It's coming over and it's providing power. For this stuff, let's put power in the middle. It does kind of matter where I put power in this one, just because of where the noise is coming from. We got this over here. Turn on thermals. Copper, I'm not gonna... 90% of what we deal with on this stream is made out of copper. I'm not dealing with that anymore. You can't, like, it's like if I put the in my name and every time somebody says the, I'm like, did somebody say the? Dear God, what is up with the thermals right now? Like an alien vision. I'm gonna wait for it to like calibrate itself, because maybe it'll fix itself. It's cool that it does this like edge tracking sometimes though. That's cool edge tracking. Oh, here it goes. It did not fix itself. I gotta plug it in again. All right, I'm gonna deactivate it. Unplug. Wait a second. Plug it back in. Activate. Code rushed! Rating of the party of 8. How y'all doing? There they are. Okay, there we go. We're trying to get not my fault for being named Copper. Yes, it is. You literally named yourself Copper. It's also your fault for being sensitive to other people saying Copper. I've heard that joke too much. That's why I'm calling it out right now. You can't just have dominion over every time we mention Copper on stream. You should unset your IRC client to ding you whenever somebody uses the word copper. You know? That's crazy. Code rushed. Thank you for the raid. How you guys doing over there? We had who dat? Why are my raids not showing up? Hold on. I'm getting raids today. Code Rush. Pope Pontus raided earlier and was trying to do stuff in what was it? Node, Java, something, and was super frustrated. So it's kind of a frustrating. How is it? How are you justifying that it's not your fault and everything is out of your control? I don't. That's so frustrating. All right, I'm done. I'm gonna test the circuit. We're gonna test the circuit. We're gonna test it with motors. It's not my fault that my IRC client dings me every time somebody says a word, but it is. It patently is. How are you passing the buck? I've been named Copper since before internet names. That's not. Kag is 1 year. Take my sub and shut up. All right. Let's see what we got over here. Let's put Kag is up on the board. No, you're just a lunatic. Like, God, all right. Anyway, Kagas, let's put you up on the board. Thank you for the sub. Eventually. Oh, there it goes. Here we go. Are you seriously? You're going to go all the way across the board, aren't you? You're going to go all the way across the board. Oh, wow, it's even messing that up. Oh, there it goes. It's like if there's enough motion on screen, it figures itself out. Okay, you didn't go all the way. Welcome to the board, my man. You got a job? Hell yeah, dude. That's not easy to do these days. Kagas, you're right by I shove all right. And oh, something Santa's beard. All right. And brown bag code. And notes and volts. And the president of Mars. And rapid all right, whatever. All right. Back over to here. Let's get this thing powered up. Now I did connect my leads, which is kind of a no-no. So I'm gonna unhook positive. This is the responsible thing to do, because when you power on the power supply, you don't know what's gonna happen over there. Best job ever. My job is basically to have a break. Like B-R-E-A-K or B-R-A-K-E. That's an important distinction. All right, power supply is booting up. The unfortunate thing about these cheapo power supply units, like they do an amazing amount of stuff. They're really effective. You can use them for a lot of variety of stuff, but they don't power up quickly. They take quite a bit to start. It's to do nothing. Is it a like a security guard kind of thing? I couldn't exist in jobs like that. I'm too. I can't do nothing. You know. That's me though. 12, 11, 10, 9, 8, 7, 6, 5, 4. Do we give it 4 volts? I think it didn't matter what voltage we did, right? I sit in the truck, wait to get to the stop, take some stuff out of the truck and repeat. Oh, damn, man. Pretty cool. Is it like super heavy stuff? Power on. 4 volts. We're approximating a lithium-ion battery. I'm starting to get a headache, man. Like, my sleep has been fucking me up big time lately. I think maybe I'm just gonna do like a bedtime. actually follow it. All right, power up. Go. Powering here. Waiting for a radio. Turn on the radio. Radio connected. We've got a little bit of flashing from the green LED, which, you know, obviously this thing hasn't been configured yet. So if I start throttling up, we should be able to see the FETs start to do stuff in thermals. That is not very fast. We're drawing almost an amp. Double tap, go in reverse. No, it's only brakes. Hold on. All right, let's God, do I not remember how to configure this thing? So that would be the, I gotta remember, pin 1. We did some real trickery with pin 1. What is getting so hot over here, and why? Why is that transistor on fire? Let's go ahead and power it down. That transistor's about to start belching smoke. This is what the thermals are good for, anyway. What would you say has happened over here? All right, it's body temperature. It's not super hot, but why you did this? Is it something due to the diode? We've got our inverting transistor coming over here, connecting to there. Our motor is still able to go forward. I don't think it has to do with the diodes, but we weren't getting like a full thing there. Tomorrow we got a 1,500 kilogram pallet. Damn. We need to put where the customer wants it, inside their house. Jesus Christ. Yeah, we paid $22.30 an hour. Hot damn, that's cool. Right. Thing going thingy over here. What's going wrong? Why is my transistor heating up? It's not like it's wired in improperly. Let's see. Let's check over the circuit here. So, pointing device. I need a pointer because my hands are gross today. Let's see. That to ground. Right, because this is active positive. That one is... Oh. No, that's correct. Yeah, okay. So that's our input, that one to ground. This one over to here. Maybe it's just a result of this thing being stuck a little bit forward bias because it's not configured. That's pretty much all I can come up with. Here's my configuration line. Oh wait, no, it's not. Wait, what is this one doing over here? Pin 6, which is... Yeah, things are a little weird right now. Hold on. 1, 2, 3, 4. Pin 7. That's not the brake light, because that's over here. What was pin 6? We can consult the schematic to figure that out. Oh no, that... Pin 7. Stupid parallax. Pin 7, I have going off into... Oh no, pin 7's input. Right, that goes to this resistor. I didn't see that. Dumb. Here, move the camera so you guys can actually see the circuit. I have an O-scope. I'm just wondering why this is hot. That's not an O-scope problem. Come on, guys. Right tools are the right application, right? It's wired up exactly like its neighbor, so I think the only real theory that I've got going as for why it got so hot, first of all, it might not have been as hot as it looked because the thermal imager ranges itself, so this might have just been the hottest thing in the circuit, which really these transistors should not be getting hot. They're just dealing with 5 volts. But it possibly could be getting warm just as, you know, by comparison to everything else. So, you know, the motor's running. We didn't get any noise, but we also didn't seem to get full throttle after we've added the diodes, which is kind of confusing to me. This one hooks up to this guy right here. So are those wired up correctly? Let's take a closer look at those. Everything is blurry. Nope. There we are. All right. This guy right here. Is this in the right direction? Probably is. This might be a result of just having 4 diodes. It could also be, the problem here could also be the fact that I don't have the 1N4148s. I don't know what those other diodes are. They were just in the bin. So that could be part of the problem here. Excuse the state of dust in the shop. This was the clean board. I guess it's gotten a little gross. Try to get an alternate angle on the light. See if we can see. No, that looks like that's the band. All right, so we got that correct. Excuse me. Is that pin properly soldered? I think it is. Yeah, it looks like that's all correct. I wonder if I go in reverse if the other LED is going to, or sorry, the other transistor is going to throw a shit fit like it did here. I need to calibrate this, so I need to take pin 1 of the controller, which is the red LED, and I will need to connect it to positive on boot. So positive on boot, like that, disconnect. So now we are in configure mode. Okay, it didn't even let me input anything. What was that about? Power off. Configure me, daddy. Ooh woo. Wait for the radio to connect. Release. Forward. And then I give it a tap. It'll test it. That's written. That's not reverse. That's operating mode. What's going on here? Oh, no. That's asking for, I forget what order I did these in. That might be reverse. I'll try it. What? Hold on. Wait a minute. It's in a weird state. What's going on here? Start over. Oh, wait. That's boot up. See, now it thinks I'm, yeah, it thinks I'm in braking mode right now. So which one was forward and which one was reverse, though? I think green was forward. Blue might be indicating reverse. I'll have to look at the code if if this messes up. All right, hold on. So let's do this. Power it up. Wait for the radio to connect. This is something that I programmed myself. This is a configuration mode. So forward, I'll hit full throttle without squeezing too hard. Beep, beep. Reverse. Beep. Beep, beep. This is neutral. Program. Beep, beep. Oh, that was supposed to be radio off. Why did it skip that? Well, that might be... Yeah, that is... Okay, so that at least gives us our forward-backwards range. For some reason, it's jumping in and out of the modes that I programmed too easily. So full throttle. Go into reverse. 1, 2. 1, 2. How's the other one going to heat up? That's kind of cooling off. Well, the diodes are working. You can see the MOSFETs are getting a little warm. And that one transistor is kind of getting a little crazy. Reverse. I'm not seeing a lot coming out of this motor, though. I'm not seeing a lot of forward progress from the motor. How are the wires doing? They're doing okay. If I go from this to full throttle, watch. Ugh! But a radio isn't disconnecting. I just don't know what's up with this guy. Why are you getting so warm, buddy? What's wrong? It's functioning just fine. Yeah, maybe blue's neutral. No, but neutral's perfectly programmed now. Like, look, I'm totally inactive in neutral. And when I throttle forward, it recognizes that green is really hard to see. I should put a different LED on that. And then I go reverse, boop, boop. See, everything seems programmed correctly. Reverse only works in slow increments, but forward should get me... Yeah, that sounds like full throttle. That does actually sound like full throttle. I just don't know why this is getting hot. Is something going on with it? Like, it's less than 10 milliamps in current draw. It's reading as 0.01 amp in terms of current draw. So is this just like idling weird? To be fair, I'm not really feeling any heat from it. You can see in comparison to my hand, it's actually quite cool. Oh, Jesus Christ, does it heat up when I go forward? Well, when I go in reverse, this one should heat up. And it's not. So I think something's wrong with this transistor. Look at that. See, this one is doing nothing. If I do partial forward, oh yeah, just a little bit of throttle heats that thing up like a light bulb. Outlet alike. Why is it happening? Ground is going to that pin there. Signal to this pin through the resistor. Resistor's there. Same value as everything else. I think it's a bad transistor. What if we flip them? Okay, it's not the transistor. It ain't the transistor. Something about whatever the fuck's going on over here. But what's going on over here? What is this? What is this? How come as soon as I give it anything, it freaks the hell out? I'm holding full throttle right now. Full stall, 1.47 amps. That's 1 amp going through this thing. By the way, the diodes work perfectly. Oh yeah, okay, so blue is the reverse light. Should have put like a white light on this so it would be like reverse lights. Typical heat of the AT-Tiny85. Undetectable by feel. And again, remember, my hand is 100 degrees Fahrenheit-ish. I really need a dummy load to go on the end of this. I need like a big balance load to put on the end of this thing. So, all right. We got like concerning amounts of transistor heat over here. I don't know why. It might have something to do with the diodes, but the diodes aren't getting hot and the transistor's still working just fine. Maybe reduced life from that transistor. The 2N2222 equivalent that I put in there might not be able to handle the heat. You know, whatever amount of current I'm putting through. My other question is whether or not I'm getting maximum out of this motor, but what we need to do right now is we need to put a beast of a motor on this thing and make sure that it's able to filter out the noise. So what I want to do, my proposition here, is to jump directly to the plasma dash. Or we could put it in charge of the car and see how fast it is. Let's put it in charge of the car and see how fast it is. I think that's more funner if I'm to use a non-word. Goodbye, typical 130 sized motor. The diodes are symmetrical for forward and reverse. Yeah, which is why I'm wondering why that other transistor isn't heating up. I mean, I've got exactly this wired up. There are two different types of diodes though, but they're symmetrically put in. All of the P channels have one type of diode, all the N channels have the other type of diode. So if that one type of diode isn't functioning properly, everything flips when you go into reverse. Braking is just powering the two N channels at once, so it doesn't have anything to do with the transistors. The transistors are on the P channels up here. This is now a bad diagram. Let me close this. Here. So the little X's are the motor pads. You can just imagine that there's a motor here with a capacitor across it. It's 4 volts is the supply voltage. So we've got one type of diode here, and then another type of diode down here. And this transistor, we could just name any one, but I'll just, where's the other transistor? Oh yeah, the other one's over here. So we'll just say that this transistor is the one heating up, right? When we're in forward motion, which would mean that we are activating this through this resistor to positive power. We have a diode from the motor to positive power, but we also have this activated because of the biasing that's occurring here. So that goes down through the motor, then this one over here is powered, and it goes down to ground. When we brake, B-R-A-K-E, we are activating both of these at once in order to stop the motor from rotating. So we're feeding back its own energy back into it, which I don't know if that violates, I don't know if the diodes hate that or not. I don't know what the diodes are doing during braking now. We'll figure it out because we'll put a drivetrain on it and see what happens. And then with reversing, we are just powering this transistor over here in the same exact way as this one. So we send positive power over here, feeds through the motor, goes to this one. Same deal. Unless maybe one of these is badly soldered? Oh God, what is it? Where is it? Maybe one of these is badly soldered? That's why I went and checked if they were all biased in the correct direction. Because like this terminal here, the motor comes in here and here. And then this one is negative. This one is negative. This one is positive. This one is positive. They're all very much soldered in place. Unless this one's still a little dodgy. No, they look pretty soldered to me. They look pretty soldered to me. Well, maybe there isn't quite as much flow over there as there needs to be. Let's try that. This is how we work through problems here. You guys get to see the sacred troubleshooting. It all looks right, though. This is the one that gave me trouble before. But yeah, that's pretty well soldered in there. So I don't know. It's all symmetrical. It should all come out in the wash. Unless that one's not soldered. This one looks soldered, though. Now, there are no solder bridges. If there was a solder bridge, then it wouldn't be able to go in reverse. And it's able to go in reverse. Now, this looks, I mean, this looks incredibly sloppy, right? But this is the test circuit. So everything will clean up when I put it on a circuit board. All right, so let's use like a power dash, which is the motor that I've got mounted into this thing. Into this thing. There we go. We got a power dash mounted in here. It's hot from me holding it. We could just use jumpers to get over to it. It's gonna overheat, but that's all right. So from there and from there, actually I should probably go here and here. So I'll go here and I'll go here. That's a little bit more direct. These don't really matter which direction I connect them in. Got a 50-50 on getting it right, right? All right, and then I throttle up. Jesus Christmas, there's no power at all. This is 4 volts, and it's not able to... Yeah. All right. Cool. Cool, man. There needs to be way more movement than this. This is not acceptable. What happened here? It's drawing 2 amps. Jesus Christ. So is this the fault of the diodes? I've got an available 10 amps from this power supply. Now, obviously, these are heating up quite a bit more as a result of the higher amperage motor. We're pushing everything a little bit more to the limits, but that is just no movement from the drivetrain. It's just not enough motor power. This thing used to scream. Like, it used to be able to go so much faster than this. Reverse is, for some reason, even worse now. Well, reverse is limited amounts of power, so it's not enough to even move the drivetrain. Okay. We're not getting any noise, but we're also not getting any power out of the whole thing. I'm giving it 4 volts, so that's, you know, a maximum 1S. But maximum 1S, this thing used to scream. This thing was fast. Gods, was I fast then. This thing was fast. So, what is going on? Are the diodes sapping my power? Is that what's going on? Unfortunately, I can't remove them very easily. Yeah, we're drawing about an amp. 2 amps, rather. Which is fine. Should be able to handle quite a few more amps than that. Yeah, at the stall in reverse, it's 1 amp. If I stall it forward, 2.3. So it's well within spec. I'm thinking that the diodes are eating my power, yeah. Might be something that's eating up a little bit of the power. Because, yeah, this is pitiful. This thing should be screaming and vibrating itself off of the table. Especially with the power dash motor in there. Like if I go direct. That's so much more powerful. There, direct, it's like, ah! That's what I'm looking for. So, something's up. Yeah, voltage drop across the diode, so we can do that. That's easy enough. Let me power down. So the weird diodes might have a bad voltage drop, or I'm wondering if the 1N4148s aren't helping. Differential calculus. Good luck, man. See you later. Almost an engineer. Yeah, so the diode testing mode is what we need. This big magnet on the back of this thing is not helping me out. All right, so diode testing mode. Not beeper mode. Wish I could delete beeper mode from the fucking thing. All right. So other way around. No, it's actually this way. Cathode and anode, all things considered. So from there to there. Okay. Okay, cool. That's cool. You know, you do you. That's fine. That's totally, you know, that's totally cool. It's totally cool. It's great. That's great. It's not even registering. Almost 1/12 if you go by my progress for the degree. Nice. Nice. We have no basis by which to measure that by. All right, so that one up there is a bad diode. Maybe that's what's causing it. This one has nothing. Yeah. Might be the problem. 0.3. 1 volt. Well, that's wildly inconsistent. This one is 0.3. This one is 1. All right, diode, whatever you say, man. 0.4. Nothing. Good day to you, sir. Huh. So I got one whose voltage drop is 1 volt. Need to measure voltage drop when running. No. Hold on. We got other fish to fry, man. Got other fish to fry. I mean, yeah, I can measure voltage across the motor and see what it's like when it's running. See what's happening there. But right now, one of the diodes isn't working. I don't think that's going to cause that much of a reduce in performance, but it certainly is. You know, something's going on there. So let's see here. That would be the one up top. If I get my probes right. Yeah, probes positioned right. It probably looks like that solder joint in front is non-existent. This one right here, not doing anything. If I can get a measurement when I poke in on this terminal. Nah, I think it's just borked. It's just a borked component. That was the first one I put in. Whereas this one gets a reading of 1 volt. And then this one gets a reading of 0.4. This one gets 0.3. These two are the most consistent. Really weird. All right, so let's get this one out of here, and we'll replace it with the only other diode that I have. The singular other diode that I have that's not a Schottky. That reduction in power is very concerning to me. I don't know what's going on there. Because these things basically should just be an open circuit to the... I mean, the FETs should just be like an open circuit to the motor. But let's get this diode out. Tweezers over here. There's so much material here that it should come out pretty easily. Yeah, how do I solve that reduction in power, right? Might be because of the diodes. These could be causing the drop. All right, let's get behind that. Go. All right, so that one's out. It is a former diode. It's a dead diode. Don't know why, but yeah. All right, that one goes away. And then we replace it with the only other 1N4148 that I've got. Well, 914 is technically the type that we're replacing it with. So if we can't get any good progress on this, I'm gonna have to quit the stream and order diodes and then do this again. God, I really wanted to get that circuit figured out, because like this one already looks like it's been through shit. Oh boy, where's that? We got the reflection just right for like a split second. Now it won't let go of my tweezers. Please get off of the tweezers, please. Okay. All right, yeah, so there's the band. So this goes this way. If it'll let go of the tweezers, which it won't, please let go of the tweezers. Please. Come on, I don't want to do this. All right, there we go. God, that is annoying. I've got a ton of Schottky diodes, but I don't think Schottkys are going to be doing it for us in this. What's up, Schmoop? I wonder if this first chat from user thing has reduced the number of bots on the platform. Because, like, you notice that I haven't gotten one of those, like, clicks for views bots in a long time. Most of my chat is just bots anyway. Paid like $5 for them. The problem is getting both of the terminals to solder on these weird... Yeah, they want to become famous. Yeah, they're just a better algorithm. Yeah, sorry man, you're a bot. I guess that's what I could call my users, the bots. The bother bots. That's not a bad one. I don't really do robots though. Robots are kind of blasé for the electrical engineering realm of things. Everybody, oh, bothers could make a robot that does the robot thing because somebody mentioned a robot. You know, I get kind of sick of that. Powered by AI and shit. That's what the human brain is. It did a bunch of trials, figured out how to learn. You keep using that word. I don't think it means what you think it means. Let's do a diode test on that to see if that actually makes contact. It doesn't look like it does, but it might actually be positioned correctly. 2.3 volts? What the fuck? The inconsistency is boggling. Point 3. 0.4. 1. 2.3. Just that bin is cursed. That bin is cursed. Nerds better. All right, we can do nerds. The oil bathers. This is why I don't let you guys make any decisions around here. All right, so yeah, these diodes. Ow, ow, ow! I just poked myself. This clay working tool was pointing right at my freaking finger. Thanks for the follow. Can you measure the old one again out of the circuit? I don't know where it is. It's gone. It's gone. I know there's like a diode in the MOSFET, but it's gone. I'll have to order some 1N4 148s or something, or some shits, and just figure out. I gotta figure out why the motor is so down on power. That's really disheartening because these MOSFETs are really good. You know, they make a good connection. They have a very low drop off and everything. As to why they're sapping all my my dispenser. I don't know. I don't know why. Stop sapping my dispenser. We need that power. Now, it should remember the settings from the radio. Should. So if I turn this on and I powered it, radio configures, we get signal, and the main screen turn on. You son of a bitch. You betrayed me for the last time. Are you serial? What the fuck is going on here? Did I hook it up wrong? Oh yeah, I hooked it up wrong. It helps if the motors are across the terminals that are being activated. That is so little power. I'm very disappointed. None of the power is getting to where it... Okay, I'm gonna try putting power closer. Probably not gonna make a difference, but try it. That's even less power now. You can see the traces are heating up too. Nobody asked what a MOSFET is. Metal oxide semiconductor field effect transistor. I'm a little pissed off at the lack of power. I mean, these are able to deliver full power. I don't think it's the MOSFETs. Oh, you misread the chat. All right. Let's look up the stats. We're gonna have to go back to the data sheet on this thing. Let's look up the stats of these FETs. I think it might be the diodes doing this dirty deed of sapping all my power away. How many definitions did you have to go into before you got that definition of otaku? All right, so the PSIA 431DJ, PSIA 431. Damn it. Okay, go to DigiKey. Is it I or 1? Oh, my foot's asleep. Oh, God. Stream over, my foot's asleep. Are you fucking serious? PSIA 431. Oh, the P, right? Because it's a P channel. I forgot. I did this last time too. SIA 431. There he is. All right, so what are we? We're a trench FET. Blah, 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 datasheet. Okay. Trench FET Power MOSFET, new thermally enhanced power pack, SC70. It is quite tiny. 20 volts, blah, 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 blah. TI, G3, blah, 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 negative 20 volts. Gate source voltage plus minus 8 volts. Jesus. Continuous drain current, 12, blah, blah, blah. Pulse drain, continuous drain diode current, IS. These are like the maxes that it can follow. I mean, when it biases, it really shouldn't be all that big of a deal. These are designed for power delivery. Show FET pics. God damn it. 250 microamps. Gate source threshold. Ba, 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 ba. Everything's like reversed because it's a P channel. Transfer capacitance. I mean, I wonder if that thing that's going on with the transistor is part of why it doesn't give us any power. But I mean, then again, it's not giving us any power in reverse either. So it's like, yeah, what kind of voltage are we getting on the outset here? I have a feeling like some of these diodes, I mean, the diodes would heat up. We would have seen them heat up if they were really sapping our power away, right? We certainly didn't get any noise. There was no shutting down of the circuits. The other thing that I can try to do is take the diodes out. Yeah, you guys are kind of barking up weird trees here. Hold on. So the deal with this is we've got 4 diodes in a similar configuration on this thing. The forward voltage of the 1N914 data chart. Small signal fast switching. We'll just look at this one because it should have similar stuff, similar stats. Jeez. Words are hard. Reverse voltage 100 volts, so we're not going to be blowing them up. Working peak 75 reverse voltage. DC blocking 75 volts, so we need like a significant spike for this thing to really do anything. That's what they're there for. RMS is 53. Forward continuous current is in the milliamps, which is fine. We need them to be fast because what we need them to do is when they are forward biased, we need them to quickly get rid of that spike. The problem with that is that the motor works in both directions. Yeah, that's all we get. We just get stats. They don't even give you the full thing, huh? Well, they give you forward and reverse, but I mean these two charts would meet up at certain spots, but whatever. Peak reverse current, blah 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 blah. All right, anyway, yeah, so we're well within the stats for this thing. Now here's the deal. Our circuit is a little strange. I mean, it's not a little strange, it's like a common filter. But we are forward biasing these when we're in a certain configuration. So if I have positive here and I have positive here and negative here, well, this one is in forward bias mode. I have negative here. This one is in forward bias mode. No, wait, negative to negative? No, it would be negative here. That one is reverse bias. Negative here, negative here. That one doesn't do anything. If I have positive here, negative here, positive should be bypassing this. Not getting back up into there. That one should be, oh, no, okay, so maybe the circuit does work. If I have negative over here, positive over here, minus to positive, that one is now in forward bias. So if I have negative here, this one is forward biased. Positive here. Reverse. Positive over here, which means this is connected, which means this one is in reverse bias. Oh, God! So, okay. So if I have positive here, that means this one is activated. Positive, reverse bias. Negative here. This one is activated. Negative to positive. That one's in reverse bias. Huh. Where does the spike dissipate? Well, the spike is supposed to dissipate when we've got some like reverse current or whatever going into this, right? I mean, yes, the FETs are supposed to naturally have a diode. That's why this is here. But for some reason they're not doing their job, or this one doesn't have as pronounced of a diode effect. That's the wrong one. This is like kind of an advanced part. They don't give you a lot of information. But yeah, see there he is. There's our little diode. I'm wondering if maybe some diodes should be in the other direction. Let's do like H-bridge diode filter. Oh boy, so many weird things. I just want an image of it. That is not... Okay, there. See, yeah, this is what we basically made. But we're so down on power in the thing. Why don't flyback diodes and H-bridge damage the power supply? Yeah. So what the heck? I think maybe I need to get the right diodes. I think maybe I need to get the right diodes. If your power supply doesn't consume the energy spike, it might damage parts connected to the power rail. It's fine, man. We've already tried the big capacitor. That didn't work. We had a Schottky diode and a big capacitor, and it wasn't able to filter out the spike. It still got back into the rest of the power system. And part of it could be that this whole circuit is spread out so much in this configuration. What was really maddening is that we went all the way back to what DOS Micro created, because that's what I've essentially reverse engineered, because we made the DOS Micro was only a 5 amp capable set of MOSFETs, and that wasn't able to handle the amount of current that these Tamiya dash motors want. They want a lot of current, and so I want to be able to give it to them. So I found these transistors, and actually originally I had these from the wltoys kit, these FETs on it, the bigger surface mount FETs. So they were doing okay. It's just I got, like, you know, crashed the RC car, it rolled on the carpet, and it like unplugged the FETs that were sitting on top of the entire model, and so that damaged it. Currently, get it? Currently, this motor uses something like 3 amps. If I connect it directly, let's see. So, well, it doesn't matter which one's negative or positive. That should... Yeah, that should have made the motor go forward. What's going on here? Did I connect? Oh yeah, I disconnected the, okay, yeah, so here. If I do the motor directly, we already did this, but we already did this. We'll do it again. That's 2 amps, and install current is 5.3 amps. 5.3 amps, which the SIAs can handle. They're like a 9 amp device. No, sorry, 12 amp. They can handle 12, so yeah, we're putting 9 through them. 9 amps through 12 amp MOSFET. Here's our schematic again. That's essentially what we got. Yeah, we're overdoing the breadboard. It's fine. It's just going to heat up a little bit. Not a big deal. Not a big deal. It's not a big deal. I was able to pull 5 amps through it right there. I mean, look. You guys seem to have a lot of book knowledge. Here's me pulling 5 amps through a breadboard. Yeah, things are heating up a little bit. I wouldn't want to sustain that. And we're not. We're not going to sustain that. You know, the wires are getting a little flexible. A little bit of extra heat. It's fine. All right, guys. So here's the deal. Let's get the diodes out of there. This is how we're doing it. We're doing it in a way that doesn't require us to get into these little numbers that chat seems to be particularly insistent on me doing. But I'm not going to go through all that. I'm not going to... I'm going to do this my way. So, I'm going to unplug this guy. We're going to get the diodes out of there, and then we'll test it directly again. Because I think we'll get the max power out of this once we get rid of the diodes. And then the question is, what diodes should I be using? Now 1N4148 should be pretty good, but we're missing a lot of power, and I want to verify, one, that we're missing power, and two, that we are actually still having the problem that we were having. We're still having the spike problem. Of course, I can add capacitors, but capacitors aren't going to get me more current to the motor right now. So let's take a look at that. Let's see if diodes are tenable as a solution to this, because it's a pretty common thing to do with your DC motor on an H-bridge circuit, is to put those diodes in there in order to filter out noise. But I'm getting a significant drop in overall power to the motor. I mean, I could measure it, but I don't care. So I'm going to take out these diodes. I mean, the fact that they were at the bottom of a bin that had been neglected for years, and they're two different types, kind of a little bit of an indicator of a possible power, or a possible problem. So let's get these out of here. It could also be that I disturbed the solder, and that killed the connection we had to the FETs. That's a possibility. So where are my tweezers? Sorry, my zip ties. What the fuck did I do with my... Hello? Tweezers? What did you did? Where did you go? What did I did with you? What the fuck did I do with my tweet? Why did they go away? Alright. You fucking with me? What the... Okay. Alright. Okay. Alright. 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 What the fuck are my tweet? Oh, they're under the vise. Alright, I found them. Treating this like Blue's Clues. Nice and toasty. I'm gonna try to pop between the terminals of this thing. Forward voltage lower than the internal MOSFET diode. Rated average current. Well, I'm not doing thinky time while I'm here. If you wanna, I'll just do something. Hold on, one sec. One sec. You're kind of jumping ahead. That's the problem. Don't jump ahead. Yes, let me put a little bit of pressure on the side of this, and then if I can get all the terminals to be molten at the same time, which is a problem when I have this much material and this small of an iron tip. One. Bro, groovy. The diodes are filtering it nicely, though. I mean, at least they're killing the spikes. Presuming that we can now reproduce the spikes right now. We'll see. If I get spikes that are killing my radio and everything, then yeah, we can chalk it up to the diodes having done their job at the very least. But something's also sapping my power, and Legoland might be onto it. But that's something to look at in a minute. I want to verify that these frickin' MOSFETs will work out. Would you just, I don't want to break the diode, but I'm going to end up breaking the diode. I guess I'm going to be ordering like 50 of these fuckers, so I guess I don't need to preserve the diode between tests here, but they're the only ones that I have, and they all seem to be damaged in some way, shape, or form. Come on, buddy. Give me the diode. Just give me the diode. Let go. Using the old tweezer spring trick that failed me. Plus, I mean, these are the only diodes that I have, so getting all choosy about diodes is not something we can do today. Possibly can in the future. Get some weird spec'd out fucking strange diodes. Oh, it's still stuck to the tweezers. Hold on. Get off of my tweezers. Go. All right. Last one. See, the weird thing is it wasn't happening just in forward. Reverse is also severely power sapped, which ain't a good look. Go. Oh, it didn't even seem very soldered on at all. Okay, so back to basics, right? Let's see what we get out of this one. So I'm going to set up my same test as before with the larger motor. We're going by sound on this one. See whether or not it sounds like it's going fast. Oop, nope, wrong terminal. Go here. Okay. Yeah. So from there, radio on. Turn on the power supply. Everybody gets up, configured, wakes up, boop. Motherfucker, it almost immediately died. It won't even go forwards. Something might be wrong in the circuit. Well, also the friggin' remote is in a weird spot. There. Yeah, it almost immediately spikes and dies. What the? Wait, was that just soldering heat, or was that is that heat that we just generated? That was soldering heat. That's soldering heat. I'll let that dissipate a little bit. Okay, so it almost immediately fails, which is incredible. Put a big capacitor on it. Actually, put a capacitor right next to the power terminals. So actually, it should go nearer to this. Well, whatever. Oh yeah. So forwards and backwards, those work. When I plug it into the motor, oh, that's a crunchy terminal. Plug it into the motor. It immediately kills it. Yeah, it immediately kills it. Well, hot damn. Okay, so the diodes were doing something. They certainly were. That's insane. So the question is, I mean, can I spec better diodes for this? I also hate how that ran out of calibration. The other thing that I can do, I can put the Schottky back in, and that gives us a little bit more functionality out of the thing. So the Schottky diode is there to do reverse protection, and it's got a pretty decent breakdown. So if I put this, it's band right there. So the band is now facing positive, which is what we want, and I'll put it on this side, on the H-bridge side of things. Just pop it in right there. Hopefully I get that right, otherwise we're going to have a bad time. Pop it in right there. Oh yeah, everything's still powered. It's only drawing 20 milliamps this time. Turn the radio back on. And then go back into this mode. Nope, wrong one. Let's do this one. And then plug the motor back in. Yeah, they are quite tiny, huh? Motor back into this one right here on the other side of the capacitor. Nothing happens. Of course, that Schottky's heating up. Did I put that in the wrong way? I don't think I did. It's getting a little warm, though. That's not the Schottky. Oh, that's just the top of the capacitor. Yeah, it still hates me. See that? As soon as I go into throttle, it just creates a fucking noise fuck. Like immediately. So the diodes are the only way to fly with this thing. We just need to get the right diodes, which is part of what Legoland is saying. Yeah, if I put the other motor back in, it should give us a little bit of motion on this. Yeah, we can move that motor. But if I go reverse... Oh yeah, because it for some reason the calibration moves like to an extreme. So reverse to full throttle. Or actually not getting any noise. Yeah, that would be a transient, right? The dash motor is giving it just the worst time. We are getting full throttle out of this. This is clearly making more noise. Without the Schottky. What I'm waiting for is to see this thing mess up. So does that match the speed of the motor without? What if I direct power the motor? Now, speed for me is a function of the amount of sound that's coming out of this thing. It doesn't sound like we're getting all the power out of it. No, the brake isn't affecting it, it seems. This is maddening. Yeah. Reverse to forward. Brake. Mid throttle. Brake. Mid throttle. Right before full throttle. There's just so little power coming out of the motor. It's really annoying. I can tell that it's not running as quickly as when it's directly connected. It could be a result of the wiring. It could be the FETs not totally connected. You know, maybe in a more constricted circuit they do better. Maybe these FETs aren't all they're cracked up to be. We can measure voltage though. We can do that. Just on an average. So I got 4 volts going in. I turn this thing to, damn it, vice is right there, which is metal. Okay, move that there, turn this thing back on. Go from here to here. So that'll load in there. No, we are getting 4 volts. Sorry, you guys weren't able to see that. Full throttle. Full reverse. Wait, 1, 2, reverse. No? 1, 2, reverse. 4 volts. 4 volts, both directions. Not able to provide the amount of current that I would like it to be able to provide, huh? Why is that happening? There's just a little bit more high frequency to the motor noise that I'm getting when I don't run it with the MOSFETs. The FETs are providing the max amount of voltage. They really shouldn't be restricting the current. I mean, that's with no load. With a load there, we'll probably see less. We'll do that, and then we will provide this and this, test leads. So full throttle forward. Yeah, we got about a drop of 0.5 volt. But that's across the motor. Reverse, of course, doesn't go as... Reverse is pulsed, so that's what we're getting there. The whole circuit is about 200 milliamps right now. So does that mean the drop-off? What does that mean for our intrepid circuit? My ability to filter out those transient spikes is quite diminished. I think maybe selecting the right diode is what's in order. Now, Initialo's comment... Oh yeah, that's right. I need to fully power this down here. You take this. All right. This is getting me into areas that I just didn't want to. Thought I could just throw some MOSFETs at it. 1, need forward voltage lower than the internal MOSFET diode at the rated average current. Well, the rated average current is 12 amps. Has to be able to continuously support that current. So 4148s would probably be a bad idea. What is the rated forward current of the 4148? Of the 215? 4148. Forward current. Forward continuous current. 300 milliamps. Yeah, that is certainly a number wang. 300 milliamps for the forward continuous current. Well, ain't that a bitch? Why would it need to be rated for 5 amps for the continuous forward current? That doesn't make any sense. Because we're not supposed to be biasing this thing in forward mode. How is it supposed to work? Up. Sorry, a little yawn there. Currently learning driving small DC voter. LN298N, good choice. Quickly get something up and running. Trying to understand what exactly is happening. Data sheet, blah, 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 blah. Spikes through the motor. For regenerative braking, they return to the general voltage. That's also return inductive spikes from the motor brushes. The supply in these may be hundreds of volts for very short duration, which can provide destructive to power supplies. Then to answer the actual question, the supply can be damaged by high voltage. All right, whatever. This is basically what chat was saying earlier, and it's stuff that we already know. The power supply is a battery. It's not going to damage the battery. Well, this is okay. So this is an RC car. So we have one power source. We have one power source, and it's a big lithium-ion battery, right? And that's a one-cell battery. So we've got, 4 to 3 point whatever going into this thing. So it's not like we can do separate power supplies for the two different things. I don't want to have a motor battery and a regular battery. That's stupid. So we got to figure out how we can keep these transient current spikes from killing our motor. Now, I don't think it's a factor of the power supply. Maybe my power supply is not able to shit current fast enough into the circuit. So I've got a big 1-cell battery that I can throw at this. But I think we were getting the current spikes even with this. So it's like a temporary thing that kind of like flicks the ear of the radio and shuts it down for just a second. So that's that motor. That's working about the same as the other one. All right, my power supply is a piece of shit. I think that's what the verdict here is. This thing is still out of adjustment. I need to lock that in. It's still so down on power, though. Well, right now, we're not running any diodes. We're running this thing full tilt. You can see all the heat in the breadboard. That's great. All right, so there's no noise when I'm running from the battery. I think maybe what's happening is the power supply that I'm using, it has some issue with the current spike. I assume you're using the diode when you switch to the bottom FET and recirculate the current back into the motor. Current doesn't change that fast, so the diode will take the brunt of for the entire off time. Yeah. Or using the diodes rather than commutating the MOSFET instead. What do you mean? What are you talking about? Commutating the MOSFET? I don't know what you mean by that. I don't know what you're assuming about what I'm trying to do with this circuit, but... I mean, I've got regenerative braking, kind of. This is supposed to be a hell of a lot faster, though. This is supposed to be much angrier than it is. I mean, yeah, we've got the full current running with this thing now with the good power supply, which is literally just a big battery. But we're not getting a full hit down here. It could be that we are still pulsing. Oh, yeah, it is. Wait a minute. Yeah, it gets a little faster if I squeeze the trigger. Yeah, braking is done by turning both of the N-channel MOSFETs on at the same time. We don't have those anymore. No more N-channel, no more diodes. Hold on, let me reconfigure the controller, because maybe we'll get a little bit more power out of this thing. That's one thing that the multimeter did not show us. The other thing is that we're not getting any spikes. Fine, I used the wrong word. It's dissipative. Oh my God. Guys, we do things a little fast and loose here because a lot of the stuffiness of electrical engineering really, really scares people away. Like, people hate it. They hate it when we get into numbers, when we do calculations, when I am stuck in a schematic. Those are parts of electrical engineering, but that's not how we operate on this channel. I try to keep it fast and loose. We're going quickly through this stuff, and I'm trying to solve a problem and do the practical steps that will get you to the answer to the problem without having to live in equations. That's how I like to operate. It might be a little bit of getting used to around here, but yeah, I don't like to do you know, I don't like to live in the textbooks here. I know what I'm doing. You guys will find that I'm able to solve these problems, you know, by going about it my way. So. During the time on the top right and the bottom left MOSFETs are on. During off time, the top right and top, yeah, it alternates the MOSFETs in order to do the H-bridge stuff. And then when it breaks, both of the negative channel MOSFETs are active at the same time. That way, as the motor spins, it's generating power that goes right back into the motor and stops it. Most RC cars, no, just letting the motor feed back into itself is one of the better ways to stop a motor. Reversing it, I mean, yeah, I could do that. I think I can get it into a mode, because I programmed this thing to do what it does, and we mostly copied the DOS Micro setup. Now I could do a different mode. I think did I leave a flag in the programming in order to do that? I could probably I'd have to reprogram it, and then I could have it just go into reverse. But if you do that, that's not gonna break BRAKE properly with an RC car, because what that'll do is, instead of subtly slowing it down, it'll flip it into reverse, and then the differentials take over, and the thing flips around. It just flips around. It just goes, it goes psycho. It breaks traction, and everything fucks up. That's not good in a tiny little RC car. What's good in a tiny little RC car is you let the motor stop itself. So it's like a sliding scale of how much braking force it puts into stuff. But yeah, okay. Anyway, I'm not going to fundamentally change how this thing works, because it's already good. Like one-on-one sessions with people to get them back up to speed. That's the problem with working on projects like this. It's hard to keep people up on the know. I don't know why I'm not getting much power out of this fucking thing. That's what's really pissing me off. This should be able to run. And when the blue light comes on, it's in reverse. This should be able to run in reverse right now. The thing is, I set the value. It's not full power reverse, because I found racing these things around, if you have full power reverse, the RC car just flies into another thing that you got to get it out of. So I do, weenie reverse, where it's like a severely hamstrung reverse. Now the thought is that I'm not getting full throttle out of this. That might be why I've got reduced power. So let me try to reconfigure this whole thing and see what happens. So what I'll do is, I need that jumper again, and I already used it. Damn it. I need another jumper. Jumper. Where my jumper at? Fine, I'll steal this. Steal this jumper here. So what I did is, at the very beginning, Google calls it a proportional integral control. You mean a PID? Skid steering, what? That's what I had. Remember when I put this thing back together, and I had the one differential on one of the sides facing the wrong direction, because you can flip them in here. So one set of wheels was going forward, the other was going in reverse. No, process ID, no, it's proportional integral derivative. During the off PWM time, which MOSFETs are on? None. I don't know why that board looks a little warm, but yeah, none of them. I think actually that's reflecting my lights. No, there are no PID controllers in this thing, man. That's... Chad, we get it, you're smart. We get it. You guys are very smart. We all know it. It's okay. All right, so... Everybody like comes in with a comment that's totally out of scope for what we're doing, right? I'm not, no. Out of scope is adding a PWM controller to the motor of an RC car. That's what's out of scope. It's too complicated for the simplicity of the system that we're making. What's up, future class DNB? Who's that? Who's that emote? Stop saying otaku. That's not right. Rollin Rizzles? I don't know who that is. No, you didn't make a funny if I didn't laugh. It just wasn't a joke. There was no joke in there. Weird. Okay, anyway. All right, so anyway, I'm going to power this thing off and power it on again, right? We're on the big 15 amp hour. I'm probably going to have to charge that soon. But what I'll do is I will disconnect the power. What I did is I programmed the ATtiny85 to check to see if pin 1 is high. So it starts it as an input, and then it flips it over to being an output when it actually starts running. He's just a buddy. Ah, that's cool. I like looking at what emotes people are using. I think that's fun to see what other channels, you know. So what I do is I connect this to positive. That could be done with a jumper on the real thing. This thing is technically supposed to be saving all these parameters. I think maybe the radio is kind of being an asshole and changing the parameters on me. So yeah, connected to power. Red LED is forced on. I'm gonna wait for the radio to finish. Take the power off. The blue LED tells us that's the reverse LED. It tells us that we're in programming mode. So what I'll do, what's the first one? Well, if the blue LED is flashing, that means it wants reverse, right? So I'll go in full reverse. Tap. Boop. And then it programs. Double flash red means it's programmed. That one is the forward LED. Full forward throttle. Tap. Programs. Writes it. Done. Now the blue LED is flashing again. Wait a minute. I think that now it wants neutral. You know, I think I programmed neutral wrong. Yeah, that might be bad. All right. Well, we'll do it. Oh, you know what? The other one was waiting. No. I screwed it up. I screwed it up bad. All right, we'll go back. We'll go back into programming mode. I could open up the Arduino program and figure out what order I did these in. It's been a long time since I've messed with this, so I need to like get into my own head to figure out what goes where. How do I strangle my own chat? All right, so start it up again. This just means get ready for programming mode, I think. Or no, it's flashing. Oh, okay, it's flashing forward and reverse at the same time, which means no throttle. That means neutral. So tap it. Programs. Now we go full throttle. Tap it. Programs. Now we go full reverse. Tap it. Programs. Now it's radio off. I think. Yeah, radio off. Because that's a different value. That's just whatever the transmitter sends. Tap it. Programs. And then we're good. Okay, cool. Glad I remembered how to do that. Jesus Christ. So now we're in radio off neutral. If the radio loses batteries, I don't want the model to fucking, like, drive away on me. That's not even applicable. Why'd you... Why are you getting... Why? All right, whatever. You guys are just not listening to chat anymore. You guys don't deserve it. All right, so forward throttle. Oh, radio on. Forward throttle full. It doesn't feel like full, but it does feel faster than it was. Reverse. Reverse is not powerful enough to move the drivetrain. I still feel like I'm sapping a little bit of power here. I hope there's not a drop across the FETs. I'll have to do a little research if that's the case. Let's measure it. It's out of the... It's like non-MIDI. What's up, Nated? All right, full throttle. 2 volts? What the shit is this? Whoa. I really don't think it's like measuring full throttle, huh? I mean, I can involve the oscilloscope to verify whether or not I'm getting a full throttle signal out of this. Hey, come back. You're not allowed to go to sleep. Hell of it. I mean, we measured 3 volts on this one. Everything changes behavior when getting hot. When things get hot enough, there's an enhanced amount of resistance because the electrons are bouncing around violently, and it's harder to get them from one end to the other. And then they end up having a higher resistance, which means that more heat is generated. There's a sort of a cascade runaway effect of heat that happens sometimes. But in this case, the FETs are getting hot, but they're doing all right. They're not hot enough for me to detect. I think maybe we're not getting. Let's verify what signals are coming out of the AT-Tiny. Hey, I could just bias the lines properly. We're not getting any power down noise. That's the good part. My concern is that this is well, what I'm thinking right now, chat, is that some of this is just because of the breadboard. Not because a breadboard can only handle 1 amp of current. That's not it, Poindexter fuckers. It's because things are so spaced out that I might not be getting good contact. I just dropped. I gotta go get that jumper wire off of the floor. Okay, so let me plug this thing in. And then the other part of this is that maybe I need to go datasheet spelunking and really kind of like crunch some numbers to make sure that these FETs are proper for this circuit. Maybe there's a, something that's not fully triggering them or something. So let's put this to ground. We don't need 2 channels. We'll just look at the 1 channel. And what are we set at right now? 2 volts peak to peak. That should do. Well, 2 volts per div. 2 volts per div. I'm going to hook a wire up with that wire on one of the parts of the circuit. We'll see what happens. Make sure not to lose these little colored collars. They help me figure out which one of these is which. Yeah, FETs can be very sensitive to shenanigans. FETs don't fuck around. They hate shenanigans. That place that Farva likes with all the funny shit on the walls. All right, let's put that there. Like wobbly. Why is that wobbly? I'm gonna move my negative terminal way in here. It's not stable at all. Why is that? Do I have 60 hertz noise on a circuit that's battery powered? What the shit is this? All right, throttle forward. Whoa, reverse is ugly. Ugly, ugly, ugly. What can you guys see? Can you guys see what I'm talking about? Yeah, you can. Reverse, ugly. It's a square wave, but it's ugly as shit. That's stable enough. Oh, that's ugly. It's just not getting enough bias. Take a look at the output for the N channel. Sorry, I gotta lean forward on top of you guys. N channel right there. Why does it look like that? What settings am I on? This is currently positively biased. My square waves aren't coming through. What the shit? What the? Yeah. So okay. So the problem is that we're not hitting our numbers with the. What is happening there? It still manages to get the FET to power, but it's probably not fully powering. So yeah, something else is wrong. Something else is the problem here. It wasn't me, somebody else. Probably still problems with this circuit right here. Something weird is going on with it. This should be a positively biased wave, or square wave. Oh hell, it's not. What the fuck? What are my probe settings? Channel 1, DC coupling, bandwidth off, 1x invert off, voltage course, unit volt. Okay, everything's set up properly. What the fuck? Okay, so shit's fucked. Shit is fucked in a unique way that I have not seen in a long time. Is it... No, it's not that. Wouldn't be that. What else could it be? Why would that not be properly? Okay, so I'm going to unplug the transistor. Now we should see a perfectly clean square wave. We don't. We just basically are seeing it go positive, and that's it. Oh, because it's the... Yeah, that's the... Okay, sorry, that's the wrong direction. So actually why were we seeing that one move? This is the one where we should see a nice little square wave. No? Oh, never mind. That's the one where we see the square waves. So what if I go back over here? Is my pin out wrong? I mean, I'm looking at the P channels. The P channel... Oh, that's right. The P channels are on and off. That's right. The P channels are on and off. That's fine. That's the way it should work. That's working the way it should work. The N channels are the ones that are controlling the speed. So this is one of the N channels. There's our square wave. Okay, so we are getting a square wave. Now it's a little spiky, but we are going to full power. Why wasn't it throttling there for a minute? Yeah, there's like noise propagating the entire system, isn't there? Jesus Christ, this thing is fucked. Why is it so bad? Well, we are okay, so the confirmation is that we are in fact going full throttle. But I am at 2.5 volts, which is not what we should be seeing. What's our input battery voltage? I didn't test that. Maybe we're not getting enough volts out of the battery. So negative to positive. Negative, positive. 3.7. We should be getting 3.7 of the MOSFETs. Whew, dropping a lot there as we throttle up. I should probably charge this battery. It's looking a little low. Although the radio does shut off when we get down below. It's alive, but it doesn't work properly. You know, do I need new FETs? Is that what it is? Do I need new FETs? These FETs are troopers, man. They were doing great. But, I don't know. Something's messing up my circuit. Like in a big way. I'm really discouraged today. This sucks. This sucks. Why am I getting such a big voltage drop? Across the MOSFETs. That's not fair. Am I maybe not like providing enough bias? No, but these things are like 1 volt they'll turn on, right? No, it's the reset that was caused here was because of spikes. I flipped over to the battery. That spike was caused by the power supply not being able to suddenly deliver 5 amps. It can deliver 5 amps, it just can't do it very suddenly, apparently, which is weird. I think it does stuff to like scale up the amount of current it's able to provide. Can you also put the DMM across the bridge while full throttle? That's what we did. What do you mean? Well, across the motor. Do you want power into the bridge? Because like that's the same thing as looking at battery power, only a little bit further away from the battery. So this is across the bridge, 3.7 volts. I throttle up. It drops like a brick. Yeah, by the time it gets over to the bridge, it drops like a brick. There's a guy in Japan making Gundam. You should look him up. Why does it drop like a brick? Drops like a goddamn brick. It's a battery. I don't know if he's on Twitch. I don't know. There's a guy in Japan. I don't know. How many Japanese streamers are there? There are a lot? I don't know if he'd stream. There's a guy who's got a whole like robot lab in Japan where they're basically making a bipedal mech. It's more like a mech warrior mech than anything else, and it only dodders around like it's got a full diaper at very low speeds. It's not that great. Some guy drove it though. I remember seeing that video. I think it was shared on the Discord. But yeah, all that shit exists. That exists. And as Osmo gets better and better and Boston Dynamics figures more shit out, people are getting better and better at high speed control systems calculating. I have no idea the name of the person I'm talking about. All right, so the deal is we've got this massive voltage drop. The battery might not be entirely charged, and the amount of copper that we got going between all this stuff is limited. Oh, is that BD? Is that who it is? Hold on, I'm just going to do something real quick. There we go. All right, anyway. The amount of copper that we have going between things might be a little bit limiting to the current. That's just because it's on a perforated prototyping board. I tried to get the power very close to where the actual H bridge is, so that wouldn't be as much of a factor. Now, if I connect it like right next to it, that might help. So let's see what this does. Move this one right here. So that's as little copper between things as possible. Oh, Boston Dynamics, that's BD. I didn't, God, I'm dumb. As soon as BD drops a video of the robots packing moving boxes, I'm getting a whole squad of them. I know, right? It's like... That sounds like there's more power. Not a lot, but there's more power. Let's check the voltage. Well, we're almost getting 3 volts there. I'm fearing, like, these MOSFETs are for, like, power switching and stuff. Why is there such a big drop across them? I mean, the only consolation here is that they're not, at the very least, I don't have spikes anymore. But if I have to use different FETs, I'm going to have a little hissy fit. Should I charge the battery? I'm not too familiar with how the battery drops off as it gets lower current. This is a lithium-ion battery. It's a bunch of lithium-ion batteries in parallel that are connected directly to this circuit. So by all means, this thing should be screaming right now. If I connect the motor directly to the battery, we're going to have a situation on our hands here. Motor directly to battery, test number 1. Positive. That actually did scare me. Negative. That's what I want to see out of this thing. Oh God, I got traction. That's what I want to see out of this thing, but it's not happening over here. It's severely limited. It's limited to like 2.5 volts. What the fuck? All right, so I got some research to do. I got to look at numbers. We're about an hour from my normal closing time. I started like 10, 15, 20 minutes late. I hate to relegate this to a 3.5 hour stream because I don't know where to go from here. I think what I need to do is I need to look up the FETs that I'm using. It could be a result of the circuit I'm making, but the problem is I want to finish this circuit. And I want to use these FETs because I don't have a lot of room for them. I mean, I can show you guys the design. Like, here is the schematic. It is an H-bridge motor controller. I do not know if these are going to kill me or not. These diodes. It seems like we don't need them, which gives me a little bit more room for the circuit itself to exist. And I got all the connections and stuff over here. So what I did, designed a small circuit board that was based on the amount of space I had in the model that I produced. So I produced a better motor mount for this type of motor. The model also has a really kind of nice, expensive servo. I created a top bar for this thing and measured the distance here and made it just a little bit smaller than that so that I'd have wiggle room there. Put it out to the edge of the pan, and then an acceptable amount of distance on the inside of this between the battery holder and the battery itself, right? So I fully modeled this thing, at least as much as I needed. And you may say, but did you need those linkages? And I'll say yes, because I'm going to be dropping a body on this model as well. Now, this doesn't exactly fit. I didn't camber the wheels so that the ball joints would fit because I didn't feel like dealing with ball joints. So things are a little clippy, but they're pretty much where they should be. I'll of course have to measure how far up the wheels go, but yeah. So everything is in here and mounted and designed and ready to go. I'm just pissed off about these FETs in here. These little FETs, these little bastards. They're not quite working out the way they should. And I want them to be this size. This is a good size for them because they'll actually fit on my circuit. I mean, if I need to use larger FETs, I guess I could probably use both layers of the circuit board because I do have a nice blank spot right underneath the FETs for heat dissipation purposes. So if I really need to make the FETs larger, it will be a little bit detrimental to the rest of the stuff on the circuit. But if I could drop the Schottky diode, which is this guy right here, drop the Schottky and then put larger FETs on this thing, I guess I could try to survive that. If that means that I'll be getting full power out of the thing. I'm so angry at it right now. I'm so angry at it right now. Why am I getting such a big voltage drop at the... I wonder if I use the other FETs, the wltoys FETs, I could just get those, but they're so big. One of those FETs is like 4 of these little ones, so that would be like dropping 8 more of these fucking things on... 12. It'd be like dropping 12 more of these guys on there. I don't have room for that. Yeah, let the bodies hit the floor. I'm angry. I'm angry. I gotta go back to the drawing board on this one. No, that's too severe. I don't have to go back to the drawing board, but I'm gonna have to pull a hat trick in order to get all this shit to fit on here. Fuck. And the capacitor should probably be there just for just to be good-natured about the whole thing, right? Although the capacitor footprint that I'm using is really annoying to solder to. No, with a 1-cell battery, you don't have any voltage regulations. You don't have any voltage regulation because all the devices in there are designed to work on that swing of voltage. So I have a 1S battery, and so I need to get all of that 1S battery into the circuit. I'm not going to put like a buck boost on it or anything like that. There are buck boosts that allow you to drain your batteries quite a long way, but part of the radio circuit is observing that voltage and shutting off the radio when you get to a voltage that is untenable, right? I think 6 is the max volts for the motor. I ran these motors on 2-cell before, and they exploded. It shredded the commutator. It's pretty fast for a little while, but right here. Oops. I think this is an Ultra Dash. But yeah, it shredded the commutator. With too much power. So, yeah, I'm gonna have to go datasheet spelunking for a good MOSFET. I have to go datasheet spelunking. It's like my least favorite thing to do. And I'm gonna take a good look at these SIIA, what are they called? The SIA series, whatever they are, the 413s, 431, trench FET, and see how this measures up. Because I did measure them up to the wltoys. wltoys is the original kit, and it does come with a motor controller that works for 2 cells. And under 1 cell, I use the MOSFETs, and they work very, very well. So the question is, do I want those? Should I just get those MOSFETs? Just give up and get those MOSFETs? I thought I could find something similarly spec'd out and smaller. Probably can find something similarly spec'd out and then smaller. The DOS Micro, under the amount of current, the DOS Micro FETs, the one they were using, were designed for 5 amps. And so it burnt up the FET to the point where the top of the silicon chip, the epoxy at the top of the chip, was glowing red, and yet it was still able to continue to control the motor. But that's a bad look. So that's why I went with 12 amp FETs. But if these things can push 12 amps, why are they fucking up at 5? Even less. It's like 3 amps. Like 3 amps to run this motor at full tilt. Dual FET packages are specialized and expensive. I mean, this is a 1-run, but you know, this is a 1-run hobby passion project. So that's mostly what I do around here is 1-run passion projects. When I get it to a certain point, by the way, if you guys want the models, I'll share them. I'll have to pack it into something that I can share. But yeah, so for this purpose, I suppose using the slightly more expensive dual FET package could work out. But I mean, these were like a slam dunk. Good in the data sheets. There is a really terrible t-shirt joke in there, but it's not 2001. So I don't know if those are selling as well anymore. Those t-shirts that just have some shitty fucking joke on them. And then everybody walking by you reads it and they're like, ah. And they get less happy. They get less happy because they've read what's on your shirt. Red hot is a little outside the official safe operating range. Yeah, just a little outside of the range. Those are like 5 or 3 amps, and it just did not like it. So I put the wltoys MOSFETs in there. Those are the ones that are on this little board right here, and those did great. But they're big. They're kind of large compared to the. I mean, here, look at the size differentiation here. So I mean, what we're doing right now is, well, what I'm doing is I'm having a little cry, having a little official cry at the amount of work that I got to do in order to vet out the rest of this shit. The FETs are not the problem. Wiring with too many jumpers, no caps near the FETs. Legoland, I don't. Well, you got it out for me, but like, I don't know about this no caps near the FETs thing. Too many jumpers. That's not the deal, man. I've got power here. The FETs are here. Ground here. The FETs are here. And I got a local capacitor on its way over. So yeah, I gotta do some datasheet spelunking to figure out why these things are dropping so much powers. Because yeah, all they do is then go directly to the motor. What? Turning off the FETs during off time? That's not... What are you talking about? That's not... What? Yeah, I don't know. I think a different specification on the FETs is probably in order. I'm going to look up what these are and give them a comparison. I don't know why that transistor was getting hot, too. That's a weird thing. That's a weird mystery that I don't really have a solution to. These funky ones, FNK 6520. And then the other one is FNK... Oops, wait. The other one is probably PNK or something, right? 6520. That one's impossible to read. 6520. Oh god, that is so difficult to read. I need to hold on. Let me get the side light in here. Shit. Oh, there goes the controller. 6520, and then the other one is 3015. 3015? 3035. 6520 and 3035. So FNK 6520. Equivalent. What the hell? Get out of here, you weird site. Oh, of course it's not going to let me leave. Look at that. It opened up 3 fucking I hate those things. Let's just do like a DigiKey. NK 6520. Those sites have gotten shadier and shadier. I really don't like them. The Alt F4 stream rating with a party of 72. Oh man, how you guys doing? I was watching Alt F4 recently. How's it going over there, everybody? We're kind of like getting towards wrapping up. Usually I'm on for like another hour. We'll see if I can draw it out to a full hour. If you're wondering what's going on here, right now what we're doing is I've got this sort of comprehensive 3D model of the RC car, the 1/24th scale RC car that I'm currently trying to build. And part of building that tiny little RC car involves putting together the motor controller and circuit. The whole point of modeling that RC car so much was so that I knew exactly how much space I had in here, and I had a more reliable motor mount where I could swap the motors out without having to drill them. So in order to do that, in order to not work on that without stream seeing, I actually got way too into reverse engineering and modeling all of the stuff that I put into this RC car. So the mechanical weirdnesses aside, don't comment on that. Don't worry about that. That stuff is because I'm not doing ball joints. I might have created ball joints, but I'm not going to motion model them and try to get that correct because it's way too fiddly. Maybe one day I will, but I modeled these approximately enough so that I could figure out where stuff was going in this kit, right? Yeah, I actually started with a photocopy of the pan and put all the dots in the right places, and then I spent a lot of time with calipers, and you know, engineers abhor numbers that are like 35.264849. So you find a datum point somewhere on the pan and get that correct. Now the actual full outside dimensions of some of the parts of it were basically just clicking and, you know, doing the arcs and stuff like that. Love your stream so much. Doing well, man. Just wrapped up myself before heading into work. Oh, hell yeah. Well, have fun at work. Thank you for the raid, man. Thank you for giving me raids. Ugh. I don't know why I like that joke. I probably should drop that joke. Ho from Germany. Well, hail from America. We're in Philadelphia, the heart of civilization as we know it. And I've got my tiny little shop here, what I stream out of, and it's literally everything that I own in this life, except for a car and a bed. I have this board on the wall over here, and that board is full of the names of people who've subscribed to the stream, including something into Santa's beard and rapid. Okay, so if you gift a sub, the giftee goes up on the board. Or if you just sub to the channel, your name can go up there. So, yeah, anyway, so I've been comprehensively modeling this RC car to get it to kind of look right. Everything but the ball joints is extensively measured and to scale and everything like that. I can get these into scale and get the camber and the toe in correct, but I'm not going to bother with that because it's complicated, and I don't feel like all I need to know is that stuff is here that moves. Hold on. Wow, my stomach fucking hates me today. Ugh. That was a burp. That was just pure pepper. Orca2040 has subscribed. Let's put him up on the board. Bop. Here, maybe I can show you the name going into the board. If I can grab the camera in time. I have to manually move the camera around. That'll eventually be fixed. But yeah, so watch the blue LED. Watch the blue LED. Blue LED will set you free. Any second now. The Twitch API is not the fastest thing in the world. There it goes. So those are all the processing steps that the Raspberry Pi was doing on Orca's name. Then it's going to send all of that G-code instruction to this Arduino, programmed with something called Gerbil, that was actually mothballed in 2019. It's water-cooled because the motor drivers were getting hot during our testing. So I also water-cooled the Raspberry Pi. It doesn't really need it, to be honest. It's kind of a meme at this point. But yeah, that moves this laser head into position on a wooden board full of names. The Raspberry Pi is responsible for getting the name, vetting it out to make sure that it fits within the font parameters that define usernames on Twitch. It will then log it to a database, grab it from the database, make it into a text box, compare that text box to a virtual created image of the entire board. When it finds no collisions, it'll register that spot, turn it into G-code, and then burn it onto my board. Orca2040, welcome to the board. Sorry I wasn't totally in focus for the whole thing of that. It's kind of hard because I got to cross the entire room in order to focus it. But welcome to the board. Yeah, next to butt stuff. Font size is entirely dependent on how many names are already on the board. Index C, subbing for 9 months, starting up a hype train. We are already at the theoretical minimum size that the board can handle, because if we burn names any smaller... Whoa! Who'd you just blast? I think you just killed Hi Mao. Sorry about the focus. It could be that dot right above the Y of Hi Mao. I think that's where it is. Yeah, that's what happens when somebody subs and the board is jogging home. It's a bug, but I'm not willing to fix it because it's funny. Oh boy, I need to refresh the water cooling system. It's kind of gross in there. Oh god damn it. Index C, you're colliding with You Love Wiener. You Index C Wiener. Well, we've got some issues with collisions. It's not supposed to collide. It could be database corruption, or it could be the way we're vetting out collisions might be a little bugged. Whisper12, thanks for the follow. But yeah, anyway, that's the thing on the wall. It's my way of thanking subs for subscribing. It is. I gotta clean up in here. So yeah, we're currently working on the motor controller for that RC car circuit, and there's some problems with it. We're not getting full power on the other side of the MOSFETs. What I was explaining is that I put all the effort into reverse engineering this whole thing. And by the way, I found an error in the wltoys kit, or at least the carbon fiber parts that I bought. Something slipped in their jig, and so they ended up drilling these holes right up on the end of the bar, and that makes nothing fit. In addition to that, the wltoys kit has a 2.5 millimeter bearing in here supporting the main drive spur gear. This isn't fully modeled, by the way. I didn't need any of the internal, you know, differential kind of stuff going on because I'm not designing the differential. I didn't need to model it, but I do need this stuff because the motor mount has a bearing support. This bearing isn't necessarily the right size, but it seems like, I don't know if wltoys ordered the wrong bearing, because in the configuration that they shipped the RC car in, there's not enough space. The transmission, by the way, that moves forward 4 millimeters. I've got it in the rearmost position right now, just because that's where that'll fit to a car body much better. But yeah, that's supposed to be 4 millimeters forward as you get it from the factory. That spur gear remains in this location no matter what. When you move the transmission backwards, you put a different, like, I don't know what that transfer gear or whatever you want to call it. That piece is elongated. So this is how it sits always, and it's supposed to sit up against this bearing. That bearing was 2 millimeters or maybe a half a millimeter to the right of where it is right now. So as shipped by the factory, those parts don't fit. I think my theory is that they meant to have a 2 millimeter width bearing, and they got a 2.5 millimeter width bearing, and nobody bothered to look. And so in assembling it, the holes don't line up. And this hole right here is like a big datum point for all of the locations of the rest of the holes of this model. Like everything kind of has an even number coming out from this. You're not allowed to self-harm on Twitch. I don't know why that's not clear. Anyway. Also, laser burns hurt, like, a lot. They're, like, really bad burns because you're destroying a lot of cells fundamentally. If you, like, people have been doing, like, laser tattoos, and it's not good. It's scarring, and it's like branding yourself, which is also a fucking ridiculously dumb thing to do. At any rate, so this circuit board is based on the amount of space that I was able to determine existed in here. I had to make mounts for 3D printing. They'll get a little bit of editing. I'm going to add posts to this one so that I can have 2 screws hold down the circuit board. The circuit board is based on the distance between this motor mount and where the servo saver sits. Now, this isn't a servo saver. That's part of the 3D model of this particular type of servo. You should know this is a $40 servo. I was not happy about having to purchase this servo. It's a good servo. Like, it's a really good servo. Like, it's all metal and it's smooth as hell, but it's so expensive, and this is just a toy that I can't even get to work right. Anyway, so I modeled something to hold on. Why is that selecting everything? Something to hold. Oh, I see. It's selecting everything because it's it's based on the pan. Yeah, so I modeled something to kind of cradle the servo, and then something to lock the servo in position. This is going to get edited so that I can 3D print it. So I will extend this post up to here, and then this will have posts that extend upwards. That one will have a peg, and then these two will have screw holes that'll fit tight. So that'll hold that circuit board in no matter what, and I can still access the screws. The motor gets a sliding front mount. I have a screw hole here that I don't really need. That was going to be for a grub screw to go in and contact this little moving bit that allows you to mesh the gears properly. But I decided to put a hole on top of it as well. So this top hole just allows you to lock in this piece, this slidey plastic piece. I'll have to gap that a little bit more so it fits properly. But yeah, the rest of this stuff, I designed this part here a long time ago. This part right here is just designed to transfer the movement of the the movement of the spindle into one singular shot. So like a shock, kind of like a race car would do. I've seen it on some race cars and stuff, so I decided to implement it. I would love to do like a full inboard suspension, but I'm not gonna get totally psycho with this because I kind of want to race this RC car around. I'm getting sick of not having it. But yeah, my challenge here was to fit everything below this center bar. So that's where this is all in Fusion 360. One of the biggest lessons that I can impart to you guys, those of you who rated, those of you who've been here a while, one of the biggest lessons that I can impart to you is all of your parts, all of your sub-assemblies, they should be brought into the model first, right? With Fusion, everything is on a timeline. So you can roll back the timeline and insert a part that you forgot to put in. What happens if I want to add something to this model is I will reverse time to where I have all of these different parts coming in. So if I go and I reverse the timeline to then, you can see all the parts are coming in and discombobulated. Is Fusion like Inventor? I think so. I don't know what the specific differences are. Fusion has a free version, but you're limited in the number of parts you can do. What you can do in Fusion, by the way, is you can have a separate drawing that has all of your parts in it and your assemblies in it, and you can pull that drawing in, and it'll just have everything in there. I don't know exactly how to work that potentially. I've got the educational license. I managed to finagle my way to getting an educational license because technically I'm educational. So that's what I use. But, oh, that's the wrong view. This is the Brady Bunch view. Okay, so, but, yeah, there's limitations on the free version. There are ways to get around it, but, so what I'm trying to, let me get back on topic here. What I'm trying to say, when you put together your Fusion model, your main assembly, all of the stuff needs to go in first. It doesn't mean it needs to go in first. It doesn't mean all the stuff should go in first, but it doesn't have to go. It doesn't make any sense. Yeah, it's immediately contradictory. The reasoning behind that is that you can reverse the timeline to where I am now. It's just a big hodgepodge of parts. What you do, yeah, it can split out. Oh, Fusion can split out blueprints too. I never played with that, but I know there is a drawings thing. But then from here, and this isn't even where I started, what I did is I took parts in, position them, take another part in, position it, part in, position it, part in, position it. And what that's going to do is it's going to create all of these part insertion steps, right? And then when you're done doing all that, you lock the position down. And then you can group all of these into one singular step. So if I want to add a part, I'd move the timeline back to where I'm adding more and more stuff. And then I double click on this to edit this step. When you do that, it has a limited amount of tools that you can use in this step, including position and align. Those are basically your only tools. You can measure stuff too. So position and align, I position the part that I just added, and then I click finish position, and then it goes and it rebuilds the entire drawing from there. All right, let's get DS4 Universe up on the board. Thank you for subbing. Yeah, so doing that keeps your timeline from getting all screwed up. Because if you're positioning and repositioning stuff and you're locking in the timeline and then you go to edit it like a drawing for a part, everything will move back to where it was back before you locked in the position. You don't want that. Any of your drawings, your sketches, should be after you lock in all of the outside parts. That's what made this model so good. Now, as I haven't messed with motion stuff yet. I don't know how to program in all the motion stuff. Why are you all the way over here? Why are you guys doing this? God, this area of the board. It's just really hard for me to move the camera over there. Whoa! Creeping out my camera a little bit there. This is like a 1990s visual effect. The camera's on a lot of extensions, and if there's not a lot of moving, things get a little weird. There it is. There it is. You've won. Let's break out the confetti. A literal 950,000th time that I've heard that suggestion. I know, you obviously you haven't been around, you don't know that. But it's like literally every stream I hear that. Hey, look, Twitch allowed those usernames to exist. Good, because you can change the parts and assembly will update. Well, therein lies the advantage of doing it in the way that I described. If you always go back to that step where you're inserting stuff and then positioning stuff and then you lock it all in, that means that all of those parts will be used when you create your 3D parts like this. So if I want to go back and edit this, all of the stuff is in there, including these, which I only just modeled. Oh, Siflet 8, 7 months. Let's put you on. So that was the 28th month for DS4 Universe. That's awesome. Yeah, I mean, the Twitch toss, you know, these are usernames. I mean, some of them have probably been banned, but Twitch could, like, send a scientist to come look at all the names on this board, write them down, and then go ban them. Because, oh, man. People have gotten pretty creative with finding names. Tell you what. Glucose level's still okay? Yeah, it's fine. Good. Dear God, could you stop fucking burning on this side of the... What is with my... You would think this area would fill up by now. I think it's just confirmation bias of hating this area. Every time it goes over here, I get angry. There, we gotta sneak in. Siflet 8, welcome to the all the way left side of the board. Future class D&B. We'll put you up on the board. Equins, welcome to the board. We'll put you up, and as soon as the database actually friggin' catches up with all this stuff, get y'all up there. Whoop. That was a blast to Admiral Alex. Was it a hit? It might be right below the D there. Keep hoping to make it on BS3, but seems to be on the Valve time scale. Oh, boo-hoo. My streamer won't make a cool board for free. I got a life, man. I'll get to it. The bin of parts is what's keeping me from moving the camera all the way to the left, so. Future class D. Fine, future class D and B. Welcome to the board. Oh, gotta move the camera. The keyboard that we repaired was working great for a little while, and then I restarted my computer and it stopped working. And so I unplugged it and I put it in timeout for a little bit. And then it just started working again. Gaff leg! 3 months, hell yeah. Who just went up? Equins. Equins. By Navigator and Fnappy and Death Soul. Bah! Another blast. Everybody's blasting everybody today. Ow. Hit my hand on something. I don't know where that one went. Possibly below Jay McManus. All right, next name. Really? Gaff leg, you're by Sir Wolf Art and Lord Squeak. All right. Well, the whole point of the board is that it's art making itself. That's why I'm reluctant to do little updates, and that's why I don't want to allow people to use 100 bits. Do you know how few fucking bits that is? 100 bits to blast? Are you kidding me? Yeah, why don't you guys tell me what I'm supposed to do next? All right, anyway, so I'm sorry I don't do everything that everybody wants me to do all the time. Jeez. So each part that I'm creating has its own like grouping to it, right? So that's the plate for the servo. If I want to go back and I want to design the servo plate a little differently, I can go back to this grouping. That's how I'm organizing this thing, and it's worked out really, really well for me. Now at the end here, I've got a couple extra steps that are not grouped up. The reasoning behind that, the reasoning behind all of this is that I'm playing around with the circuit board, and when I get that finalized, I will put that, and well, I don't need to put its mounts into a group. I'll probably put it into the insert stuff step. So, anywho, that's how I've been organizing this, part by part. All the drawings, all the extrusions are in their own category that I can go back and I can edit. And then, of course, with Fusion, the wonderful part is that I've got all of the 3D printable stuff here in the bodies that I've extruded. Right-click, save as mesh, choose the right file type, pull it into Prusa, hit print, and then boom. I got a little tiny 3D printed servo mount. It's impossible to see. Yeah, you can. I don't know how you make them like different colors and stuff, but like this one is motor front. You see at the bottom of that, all the steps, it has the name of the category. Okay, you can do right click and then rename right there. Also edit sketch, huh? So yeah, all the bodies, they start with a sketch. Sketch on a surface, extrude, new sketch, extrude, chamfer, extrude, fillet, extrude, chamfer, blah, 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 etc. until you have your part, right? So that's how I've been organizing it. It's been working out for me. But yeah, the problem that we had is in order to run this tiny little circuit board, I wanted to copy the DOTS micro motor controller. This is a very basic motor controller. It exists on an 8-pin IC. We did a lot of work programming it in order to get it to function the same and have all the features that I wanted it to. In order to fit it on this board, I need everything to be very, very small. And so I chose MOSFETs that were very, very small. I looked up on DigiKey. I found these little goobers right here. They seem all right, but there's a significant voltage drop when they go to power the motor. I don't know why. It's, you know, a lot of the stuff that we've been trying hasn't really worked out all that well. So I'm back to the drawing board a little bit on it. I know how much room I have to build these things in. If I really want to, I could probably squeeze a couple millimeters out of the top of the board. I don't want to have to do that, though. I could probably get a little closer to that. Mr. Pythons! Thank you for following. Autodesk is so pretty, but so expensive, yeah. So, this software... No, it's just the DC motor. I wanted to stick to the DC motors because Tamiya makes this dash series, these dash series motors, Ultra Dash, Plasma Dash, Light Dash. They're very, very powerful for what they are. And the motor in these things, in a 1/28 scale RC car, the motor is already completely overpowered, right? I don't want this to go super duper fast. In fact, this originated as a way to cheat at Mario Kart Home Circuit, right? Because I got 2 of those fucking Mario Kart Home Circuits and I want to modify one. We'll do that someday, but this is a brushed DC motor. It's just a common, you know, DC motor. It is powerful enough that it can power this model. Now, BLDCs do better at low speeds because you've got more control over them. So that might be an advantage of going 3-phase with this, but I'm not going 3-phase with this. People absolutely pile the control stuff on top of the frame of the RC car. Like, you look at these things and people have like all of these electronics sitting on the top. I'm not doing that. I want this thing to be compact and neat and fun. So anyway, you know, drifting is totally possible with these motors. Yeah, what was I saying about Fusion? Fusion is expensive if you buy, you know, a version that can handle a lot of parts. There's a free version. Fusion also has Eagle integrated into it, so you can do electronics designs. And if you're choosy as I am, you'll look for library parts that have three-dimensional models associated with them so that you can get an idea of what you're designing for your board, and you could do an enclosure around it, and you can do cool board shapes and stuff like that. I still need a Toper router for this though. That would be the best. Toper just is point-to-point routing. It's cursed. I love it. I wish I could use it. Anyway, so yeah, this is the educational license for Fusion 360, which is for educators. So I put some things in forums, and I didn't lie, so I've still got this license, and I'm technically educating on Twitch. Yeah, you can't deny that there's a little bit of education going on here. So technically, I could possibly use this version without issue. But if push comes to shove, I'll go to the free version, and then I'll really evaluate whether or not I want to spend, what is it, like $300 a year or something on this, because I don't know if I want to. But yeah, for the time being, using Fusion has been very nice. If I had the limited amount of parts for the free version, you can get around the limitations if you're careful. And there are ways to do it. I'm sure you could look up online how to get around the limitations, but I don't have that limitation, so I may be doing stuff with my parts that you can't. Either way, I went a little crazy modeling this thing, but it's working so far. The only thing I got to do is go back to the drawing board and find the right MOSFETs. We got a big voltage drop across the MOSFETs. I'm going to charge that battery too. $495 a year, so it's like Adobe pricing. Yeah. I mean, I'm not making money off of Fusion. I don't make any money off of it, so I'm not going to get that paid version. Eagle's what I got used to. It used to be the hobbyist's go-to for board design. I got used to Eagle, and I kind of know how it works. They need to do a top-to-bottom rethink about how these files go together, about how the library of parts works, because it is a mess. And if they clean that up, I'll be so happy. Have you ever sold any of your projects? No. One day I'll come up with something. The problem with this one is that we basically reverse engineered the DOS Micro stuff. So it's technically DOS Micro. Even though I did design my own circuit board in order to mount all the stuff, it's still all DOS Micro. The MOSFET requirement, we've got, I think, 3 to 4 volts, switching them, and they need to handle well over 5 amps. So I chose 12 amps for the MOSFETs. Yeah, Fusion has circuit board stuff in it. That's how I got the models of the good. So Eagle, nowadays, Eagle, if you use the right parts, those parts have 3D models on them. So if I insert a part into this drawing, I need to clean all this shit up too. I need to make sure that I've got models for everything. But if you do like a managed library, you have your schematic symbol, Turbo Vision. Thank you for following. Those are like a pair of sunglasses that I bought in the 80s. You have your schematic diagram, you have your footprint, so you can design the board, and you have a 3D model that's placed on top of the footprint. Notes and Volts had a better program than Eagle? The day when they deny my educational license, I'll have to look that up. But yeah, the 3D model is like the important part about this. So when I drop the parts down, we'll just do an example. I'll drop that audio jack down, even though I'm not using it. So I'll then use the button to switch to the 2-dimensional board layout. Now that I've done that, I've got this part sitting here. This is the headphone jack we used for Tom Thinks' button. You guys don't know Tom Thinks. He does like live puppetry on Twitch. It's totally amazing. He has a Roland voice changer and a lot of buttons. A lot, like he's got like a lot of buttons. He pushes a lot of buttons. Yeah, thank you for doing that shout out. So Tom Thinks does live puppetry on Twitch. He had an ankle problem. I think it's an ankle problem. Some kind of a repetitive stress injury is what I called it. And he had a lot of trouble with his ankles. He tried a standing desk. He tried a sitting desk. When you're sitting down and you're using the Roland voice changer foot pedal, the positioning, especially when you're standing, your foot needs to be like this. So he turned it to like a push on, push off mode. If my stomach could let me talk. Push on, push off mode. And that still didn't work. He was still having a lot of trouble. So he tried like taping a button to a circuit board, and he'd like hit it with his knee and all that stuff. And I was like, and I was like, dude, I'm gonna make you something. I'm gonna make you something that'll allow you to push these buttons and you know, go about your day without fucking ruining your body. So we did a little bit of work, and we were able to make what was the working title was Thurston Thumbbar, but it is a 3D printed button that he's able to put on his desk and use. What just happened? what just happened? All right, he's able to put this on his desk. And I put his toot emote on the top of it, but that has a little headphone jack on it on both sides, so that he can actually plug that into his Roland voice changer. And the way we were able to do that is with Fusion, making a circuit board and then having the three-dimensional circuit board based on the size of all the stuff, and then designing all of the parts around that. So I could 3D print all these different parts and put together his button. The problem is this button piece, if that ever breaks, I only had 2 of them, and I sent them both to Tom. I built 2 of these things, I sent them both to Tom. So Tom thinks it's both of these. He has 2 of them, so if one breaks after 10,000 years, he's got 10,000 more years with another one. He could use them both at once, but yeah, he absolutely, like, every time I'm in the chat, he's like, oh, there's a button, look at this. It's cool. That was a slam dunk of a project, by the way, guys. These are few and far between. Projects like the Toot button, few and far between, where you know that you can lend exactly the right skill set to exactly the right problem. But yeah, so that's what we designed for Tom. But that uses this headphone jack. So with Fusion, don't save. With Fusion, you can insert the part into the 2-dimensional drawing, and if you click this little guy right here, if you've got all the 3D models worked out, there are a couple different ways that you can find parts. You can use GrabCAD. You can go on DigiKey or Mouser, and you can search, and then there's a little filter box that you can check that allows you to search for only parts that have a 3D model included with it. So part of the information for the parts is a 3-dimensional model that the manufacturer has provided. So you can pull those into Fusion. And what I do is I pull them into Fusion, and then I do the appearance dialog so that you can change the appearance of them. So you get all the materials right. You know, everything that's plastic looks like plastic. Everything that's gold looks like gold, metal, etc. It's got all the materials in Fusion that you can use. It's cool. So from there, if I've got all my parts sorted out, and by the way, the library editor and the parts creator, it needs help. It needs help. It has mental problems. It is like something is broken in its brain, and it is the least intuitive, clunkiest, fucked up. I hate it. I need to remake all of my libraries, my connectors, components, etc., and give them 3D models. I can never remember the workflow, and the workflow is just psychotic. It's all over the place. So it takes a concerted effort in order to put all that stuff in there. And once you've done it, it's like you're going to be using Fusion forever. But anyway, so from there, if I've got all that stuff sorted out, I go to the 3-dimensional model of the circuit, and then it places all the pads, all the traces, all of the models, everything to where you've designated them. And so you get this gorgeous looking circuit board model out of the whole thing. And then here I've got a floating audio jack that has pads in space. But yeah, you get this wonderful looking 3D model of your board. You can change the board color too. That's in one of the tabs of the 2D circuit editor. All right, I need to get this out of here before we convene. So what'd you find, Zachary? DMT 8012 LFG. My only doubt is slightly high gate capacitance. Gate capacitance is okay, right? Well, I'll look up that part. I'll see if it fits. It probably does. you know, I have to apologize, guys, but I do try not to let chat drive me during streams, because I know you guys know what you're doing, but it's better. I would rather show the struggle than anything else. I'm trying to get the updates of all this. I gotta save everything and close it out from this, because I'll be using this on my other computer, especially if I have to order MOSFETs, and I guess I don't have to order diodes anymore. Those diodes did a great job of filtering, but with a 1S battery hooked up directly, we don't have any troubles with, like, I guess the voltage is dropping from the battery, and that's what's causing the problems. And a lot of it is probably that the perforated prototyping board is spreading everything out a lot. So I don't think these FETs are really gonna benefit me, the ones that I chose. I would love to know. Okay, can we get my arm out of the shot? There we go. I don't think these FETs are gonna work. They're part of the problem, is my understanding. I don't know what the problem specifically is. Maybe they're not switched all the way on. Yeah, I'll have to look at them off stream, because I'm not gonna do numbers and spreadsheets on stream. That's like an ironclad rule around here. I'm gonna have to vet out what FETs I want to use. My backpack's got jets. I'm Boba the Fett. I bounty hunt for Jabba Hutt to finance my vet. So when I save this model, this is the model that I took into the RC car model. When I save that model, what's going to happen all the way back, the tabs, I don't have room for all this stuff. If I go back to my main model, the one that I'm basing everything on, there is now a little caution flag. Oh, by the way, the 3D PCB, the most annoying, one of the most annoying things here is that the 3-dimensional PCB is what determines the location of holes on the board. So when you do that model, you need to have a little precognition. If you're going to, if you make the circuit board to be its absolute maximum size, and then you need to make something around it, you have to go to the 3D model in order to add holes to it, because here's the hole tool. So if I add a hole, theoretically, I put it there, I give it a diameter, but I need reference points. So the reference point in this case would be one edge of the board and then the other edge of the board, and then I can manually put in those dimensions in order to put it in a good spot. And the hole doesn't have any stuff around it, right? What would you say would be the charge range? I have no idea. I have absolutely no idea. So what I had to also do was take that location, those numbers, and then put a silkscreen line around it. So a discrete gate driver. Yeah, a discrete gate driver would be for more like higher powered stuff, right? Like we shouldn't need that in this circuit because we've got 4 3 volts hitting that thing all at once, and that takes like 1 volt to switch that FET. So I don't think that's it. Maybe that's it, but I'm not totally sure. Anyway, I had to go back and forth between them in order to get these screw holes in the right spots. Well, acceptable spots, right? Those are acceptable spots for the screw holes. Other stuff I don't really know quite how to do. But yeah, so once all that stuff updates and I save that file, I get this little caution thing here. Update external references. You're not going to see anything happen to this. But then all those changes go into the board that I've put on here. So that's a little bit of how to like utilize the full breadth of Fusion's sort of integration of different tools. There are other tools that are integrated into this program that I've not even gotten close to. Like motion and like mechanical engineering stuff that I'm just never going to touch. The electrical engineering stuff I love because I can then, from here, from having a 3-dimensional circuit board with some of the extra parts that I've added onto it, I can then do the stuff like designing an enclosure around it, figure out what fits where, figure out where my capacitor goes before I actually commit to buying the full board from a place. You've used them in low power design. Needed it between my FET and micro because the micro couldn't shove enough current. Huh. Even though it could get the right voltage slowly. I wonder if that's a possibility. Because if you notice the way that this thing worked, and I think that was more of the drivetrain, but it started slow and it eventually sped up. I don't want to have to incorporate lots of extra parts, right? I want this thing to just hammer the FET into the open state or closed state or whatever you want to call it. That's going to be something that I need to like vet out. I really want to finish figuring this shit out. I'm so sick of this, right? You can scope the gate and see the switching speeds. We did, didn't we? We looked at that. We had it on the scope. There was like a spike, and then it kind of came down to the square wave. But I guess I need to put that and the output on 2 channels and see what that looks like. I wonder if that's the problem. All right. I'm gonna end here though, because I'm dead. On Thursday, I would like to work on the computer, not my normal computer. I was gonna put that motherboard, the one that's the B5, the super duper motherboard that's sitting behind me. I'm gonna put that in my regular gaming computer soon. I was this close to doing it today because my Vive wasn't fucking working. It had all these connection troubles. When I finally got it working, and what did it for me was plugging USB in last. The last thing to plug in was USB. Then I had to unplug the plug that's on the headset itself and plug it back in, because that was intermittently disconnecting, and then it would lose sight of where everything was. Absolutely frustrating. The design of that thing is some of the little pieces of design on that thing are not great. So that was if that didn't work, I would have been installing a motherboard into my computer today. Thursday, we're going to work on a different computer. It's a computer that's actually currently streaming right now. This computer, I want to put in a rack mount case. I've got a rack mount case. It's sitting right there. It's right under my arm. That's the rack mount case. I'm going to water cool it because it's funny. Oh, it's fun. So it's going to have a reservoir in the front, all the accoutrement. And so we're going to have to do the same thing that I did with my regular computer. We're going to design things that go into those rails. Yeah, I'm going to run it. I'm going to be streaming and transferring the parts from one thing. No. That'll be done off air. But what I need to do is design the parts that are going to be 3D printed for that. I made the fan adapter that's sitting right there. We'll look at that. We'll look at how that fits, try to fit it in. And then we'll figure out what other 3D printed parts go around it. Once that's done, and I've got everything sort of physically mounted, I then can spend off-stream time transferring all the stuff over, and I'll have the computer rack mounted finally. I've been wanting that for quite a while. Yeah. And then on Friday, we got to look at that storage device. So, all right, that's what we're going to do on Thursday. I'm not going to be around on Wednesday. I'm going to leave you guys to the void. Thank you, everybody, for the raids. And thank you guys for watching today. This has been a little frustrating, but I think we're on the right track. I think maybe the FETs are the problem. I should have predicted that. I like those little FETs, though. They're really nice. Well, we'll look at a couple stuff. I'll look at some stuff on Wednesday. I got to order parts, I think. FETs, not diodes anymore. I still need those 1 and 4 1/4/8, though. And, yeah, I'll see you guys on Thursday. I'll see you guys on Thursday. Get out. Get out of my shop. Why are you still in my shop? I told you guys to leave. It's getting, like, really awkward. Why are you guys still here? Ugh.